Good evening. Tonight, we are setting aside the modern world, the lights of our cities, the sound of passing cars, the steady rhythm of daily life. All of it can quietly drift away. Instead, imagine yourself floating gently through the darkness of space. There is no rush, no destination waiting, only endless silence, and countless distant stars. Far ahead, a small blue planet slowly comes into view. But something feels different. The continents are unfamiliar. The oceans seem restless. The air carries no birds. No forests cover the land. No flowers bloom. No animals leave footprints along the shore. You are looking at Earth, not millions, but billions of years ago, nearly 4 billion years in the past. This world is still young. Its surface is only beginning to settle after a violent birth. If you could somehow stand here, the ground beneath your feet would feel warm, sometimes hot. The planet still holds much of the heat from its formation. Deep below the surface, molten rock slowly stirs, like a glowing heartbeat hidden beneath a thin shell of stone. Across the horizon, great volcanoes quietly release clouds of steam, carbon dioxide, sulfur, and gases unlike the fresh air we know today. The sky has no bright blue color. Instead, it carries shades of gray, orange, and deep reddish brown. The sunlight filters through a thick atmosphere, softened by countless particles drifting high above. The moon appears much larger than it does today. It hangs low in the sky, its pale surface watching over a planet that has only recently become stable enough to begin an extraordinary journey. The days themselves are shorter. Earth spins faster than the modern world. Morning arrives more quickly, even though there is still very little to greet the sunrise. There are no trees stretching toward the light. No birds welcoming the dawn. Only stone, water, steam, and silence. Imagine drifting above this ancient landscape, like a gentle cloud, watching enormous rivers of cooled lava winding toward distant seas. The ground is rough, dark, and newly formed. Each mountain, each valley, each coastline is still finding its shape. Nothing has existed here for very long. Everything feels wonderfully new. The oceans below are vast, but they are unlike the clear blue waters of today. They carry dissolved minerals washed from fresh volcanic rock. Iron flows freely through the water, giving many places a greenish or rusty appearance beneath the changing light. Tiny waves roll endlessly across the surface. There are no ships, no whales, no coral reefs, no fish darting beneath the waves, only quiet water, patiently waiting. Above, clouds gather once again. Rain begins to fall, not for an afternoon or a season, but through countless generations. Gentle showers, powerful storms, warm rain that slowly cools the surface of an ancient earth. Each drop helps shape the planet, carving valleys, filling basins, building the oceans that will one day cradle every form of life. Time moves differently here. A single mountain may stand unchanged for millions of years. An ocean slowly grows deeper. A continent drifts only a few inches each year, too slowly for any eye to notice, yet enough to reshape the world over unimaginable ages. If we measured this history using a single calendar year, everything humans have ever experienced, every civilization, every invention, every story, would appear only during the final few seconds before midnight. Everything before that belongs to worlds like this one. A peaceful Earth, still preparing itself. Nothing here seems alive. And yet, the stage is quietly being set. Every ocean basin, every mineral, every warm shoreline, every volcanic vent will soon become part of one of the greatest stories the universe has ever told. The story of life, not with thunderous fanfare, not with a single magical moment, but through countless tiny changes, so small, so gentle, that no observer could ever notice them happening in real time. For now, the planet simply breathes. Steam rises, rain falls, waves whisper against empty shores. The moon slowly circles above, and beneath those quiet waters, invisible possibilities are beginning to gather, where the endless rain will finally become the oceans that cradle the first fragile ingredients of life. Take another slow breath and let yourself drift a little farther back into Earth's distant past. The young planet is quieter now than it once was, not because every volcano has fallen silent. Far from it. Deep beneath the surface, Earth is still wonderfully alive. Rivers of molten rock continue to move through its hidden interior, creating new crust, lifting mountains, and gently reshaping the face of the world. Yet something remarkable is changing. The furious bombardment that once scarred the planet is becoming less frequent. The giant impacts that melted entire regions of Earth's surface are growing rare. Little by little, the young world is beginning to settle. Above you, dark clouds stretch from one horizon to the other. They are unlike the clouds of today. There is no cool breeze carrying the scent of pine forests, no sunlight sparkling through blue skies. Only endless layers of warm vapor, slowly gathering into immense storm systems. Then, the rain begins. Soft at first, almost gentle, tiny drops touch the hot volcanic rocks with quiet hisses, vanishing into steam before they can rest. For millions of years, this happens again and again. The surface remains too warm to hold water for long. Each shower briefly paints the landscape with silver streams, only for the heat below to lift everything back into the atmosphere. It is a beautiful cycle. Water rises, clouds form, rain falls, steam rises once more. Over countless ages, the planet slowly cools, not overnight, not over centuries, but over millions of patient years. Eventually, something changes. This time, when the rain falls, it stays. Small puddles gather inside ancient craters. Thin streams begin flowing through cracks in the young rock. Those streams join together, forming rivers unlike any that have existed before. Every drop follows gravity's quiet invitation, always moving toward the lowest places. Imagine floating above this newborn landscape, across vast plains of black volcanic stone. Silver ribbons of water slowly weave together. Some disappear beneath fresh lava, others carve gentle valleys, never realizing they are shaping continents that will exist billions of years later. The sound is wonderfully peaceful, rain tapping softly across warm stone, tiny waterfalls tumbling over jagged cliffs, steam whispering into the sky. No birds interrupt the silence. No insects hum nearby. Nature's orchestra has only begun tuning its first instruments. Century after century, the rivers continue their endless work. Eventually, they reach enormous basins. Water collects. It rises, then rises again. The first true oceans begin to appear. These ancient seas look very different from those we know today. Their color is not the familiar deep blue. Instead, the water carries dissolved iron, nickel, silica, and countless minerals released from Earth's youthful crust. Some regions shimmer with shades of green. Others reflect rusty reds beneath the hazy sunlight. Yet despite their unusual colors, these oceans possess something profoundly familiar. Every wave, every ripple, every gentle current belongs to the same bodies of water that still cover our planet today. If you dipped your hand into those ancient seas, some of those very water molecules might still exist somewhere on Earth, perhaps floating today inside a quiet Pacific wave, resting within a glacier, or falling gently as rain outside someone's window. Water has an extraordinary memory, not because it remembers, but because it continues its endless journey, always moving, always changing, never truly disappearing. As the oceans deepen, the shoreline stretches farther each year. Tiny islands become coastlines. Hidden valleys disappear beneath calm water. New beaches are formed, only to vanish again as sea levels slowly rise. Far below the surface, something equally fascinating is happening. Cold seawater seeps through cracks in the ocean floor. There, it meets hot rock heated by Earth's interior. The water absorbs minerals, becomes superheated, then rises once more through towering hydrothermal vents. These underwater springs pour warm, mineral-rich water into the surrounding sea, like gentle chimneys breathing into the darkness. Today, scientists still find these remarkable places thousands of meters beneath modern oceans. They support entire ecosystems without sunlight. But here, billions of years ago, they may have offered something even greater. A peaceful meeting place where water, heat, minerals, and chemistry quietly gathered together. No one was there to witness it. No eyes watched the waves. No creatures explored the shoreline. The planet itself was the only observer. And still, it patiently continued preparing. Every rainfall, every mineral carried downstream, every underwater spring was slowly building an environment unlike any that had ever existed in the universe. A place where ordinary ingredients, given enough time, might begin doing something extraordinary. For now, the oceans simply breathe. Gentle waves rise and fall beneath a silent sky. Warm currents drift across an empty world, and hidden within those peaceful waters, the smallest building blocks of life are beginning to gather. Now, let your thoughts drift upward, away from the quiet oceans, away from the dark volcanic shores, and toward the sky above this ancient earth. At first glance, it is still beautiful. The sun rises each morning, its warm light spreading across the restless sea. Clouds continue their endless journey. Gentle rain still falls. Yet if you could somehow take a single breath, you would quickly discover that this world is nothing like home. The air is almost completely missing the one gas that every animal today depends upon. There is almost no oxygen, not enough for birds to fly, not enough for forests to grow, not enough for a human to survive even a few moments. Instead, the atmosphere is filled with carbon dioxide, water vapor, nitrogen, methane, and traces of volcanic gases drifting upward from thousands of active vents across the planet. It might sound unfamiliar, but in many ways, This atmosphere is doing exactly what Earth needs. Carbon dioxide acts like a warm blanket around the young planet. Although the sun shines about 30% less brightly than it does today, Earth's thick atmosphere helps trap precious heat. Without that natural greenhouse effect, much of the ocean might have frozen solid. Instead, liquid water continues flowing across the world. And liquid water, as we know, will become life's greatest companion. Imagine standing beside one of those ancient coastlines. The air feels warm, moist, heavy. The scent is unlike anything in the modern world. Hints of sulfur drift from distant volcanoes. Steam rises from cracks in the ground. Fresh rain carries dissolved minerals toward the sea. Everything smells of stone, water, and fire. Above, the sky itself appears different. Without abundant oxygen, there is almost no protective ozone layer high in the atmosphere. Today, that invisible shield quietly blocks much of the sun's harmful ultraviolet radiation. But billions of years ago, the young Earth stands almost completely exposed. Powerful ultraviolet light pours through the atmosphere, bathing rocks, oceans, and shallow pools in energy. To us, that might sound dangerous. And indeed, for modern life, it would be. But this is not yet a world of delicate plants or animals. There is nothing here to fear the sunlight. Instead, that constant flow of energy becomes another quiet ingredient in Earth's long chemical story. Imagine millions of tiny molecules floating in warm pools near the shoreline. Each day, sunlight strikes them. Some break apart, others combine. Most changes accomplish nothing at all. Yet every now and then, a new arrangement appears. A slightly more stable structure, a different combination, a fresh possibility. Nature is performing countless experiments, without intention, without planning, simply because energy keeps flowing into the system. Lightning joins the process as well. Across the dark horizon, great storms slowly build. Warm air rises. Clouds tower higher and higher. Then, a brilliant flash silently illuminates the sky. For a brief instant, the clouds glow white. The sea reflects silver light. Then darkness returns. Again and again, every bolt delivers enormous amounts of energy. Modern laboratory experiments have shown that when simple gases similar to Earth's early atmosphere receive electrical energy, some of the basic building blocks of life can form naturally. No single lightning strike creates life. But over millions of years, with storms occurring across an entire planet, the opportunities become almost endless. Imagine watching this ancient weather from high above. Clouds slowly circle the globe. Rain sweeps across newborn oceans. Lightning flickers like distant lanterns beneath the stars. There is no audience, no witness, only Earth, patiently carrying out one quiet experiment after another. Even the stars overhead appear slightly different. The moon is closer. The constellations have shifted over billions of years. Some familiar stars have not yet formed. Others shine more brightly than they do today. The night sky feels wonderfully ancient, calm, timeless, silent beyond imagination. As darkness settles over the oceans, gentle waves continue rolling toward empty shores. Steam rises from warm springs. Volcanoes glow softly along distant horizons. The atmosphere breathes, not with oxygen, but with possibility. Every gust of wind carries tiny molecules across continents. Every rainfall mixes new ingredients together. Every sunrise delivers another day's worth of energy. Nothing appears alive, and yet, the chemistry of life is quietly becoming more likely with every passing million years. The sky itself, though unfamiliar, has become an essential partner in Earth's greatest transformation. Without its warmth, without its storms, without its lightning, and beneath those peaceful waters, where sunlight reaches into the shallows, the first tiny organic molecules are beginning to appear, waiting quietly to meet one another for the very first time. Take another slow, comfortable breath as the gentle waves fade behind us. Our journey carries us inland, toward the restless heart of the young earth. From far away, the landscape almost seems peaceful. Dark mountains rise beneath a hazy sky. Clouds drift slowly overhead. Rain falls in distant valleys. But as we draw closer, a quiet glow begins to appear along the horizon. The earth is still very young. Its interior remains astonishingly hot. Much of that heat comes from the incredible violence of its birth, when countless pieces of rock collided, merged, and slowly formed the planet we now call home. Even billions of years later, that ancient warmth has not completely disappeared. Deep beneath your feet, far below the solid crust, an ocean of slowly moving rock continues its endless dance. It does not flow like water. Instead, it moves almost too slowly to notice. Only a few centimeters each year, yet over millions of years, those gentle movements shape entire continents. Every so often, pressure quietly builds beneath the surface. Hidden chambers fill with molten stone. The surrounding rock bends, then cracks. Without warning, a volcano awakens. Imagine watching from a safe distance. A low rumble echoes across the empty land. Not frightening, only deep, like the peaceful heartbeat of a sleeping giant. Then, a glowing ribbon of lava slowly emerges. It pours down the mountain, not racing, but flowing with calm determination. Bright orange beneath the dark sky, its surface gradually cools into black stone, while fresh molten rock continues flowing underneath. As the lava reaches lower ground, steam rises where it meets rainwater. Gentle white clouds drift upward, carrying warmth into the ancient atmosphere. There are no villages to threaten, no forests to burn, no animals searching for shelter. The volcano shapes an empty world. Patiently, quietly, almost artistically, one eruption ends. Another begins hundreds of kilometers away. Across the young earth, thousands of volcanoes are active. Some stand high above the land. Others remain hidden beneath the oceans. The underwater volcanoes are especially fascinating. Far below the surface, where sunlight never reaches, molten rock pushes through cracks in the ocean floor. Cold seawater touches the fresh lava. Instantly, clouds of mineral-rich water billow upward. These underwater eruptions build mountains no one will ever see for billions of years. Some will eventually become islands. Others remain forever beneath the sea. Together, they slowly create new ocean floor, expanding Earth's surface little by little. Imagine drifting above this ancient planet from space. Across the dark hemisphere, tiny glowing points appear. Not cities, not campfires, but volcanoes. Hundreds of them, perhaps thousands. each one quietly releasing heat from Earth's interior. The planet almost resembles a living lantern, its gentle orange glow flickering beneath drifting clouds. Volcanoes release much more than lava. With every eruption, invisible gases escape into the atmosphere: water vapor, carbon dioxide, nitrogen, sulfur compounds. These gases will help shape Earth's climate for hundreds of millions of years. Without them, the atmosphere would have evolved very differently. The oceans might never have remained warm enough for life's earliest chemistry. Even the rocks themselves become important. Fresh volcanic stone contains countless minerals. Rain slowly wears those rocks away. Tiny particles wash into rivers, then into the oceans. Iron, magnesium, phosphorus, calcium, silica. The sea becomes a rich chemical soup, not by accident, but through millions upon millions of years of quiet geological work. Every eruption, every rainfall, every flowing river adds another small ingredient. Nature never rushes. It simply continues, patiently mixing, patiently preparing. Scientists sometimes describe Earth as a giant recycling machine. Even today, volcanoes continue returning materials from deep inside the planet back to the surface. Old rocks melt. New rocks form. Mountains rise. Mountains slowly disappear. The cycle never truly ends. Here, in Earth's earliest chapter, that cycle is only beginning. The landscape changes constantly. A coastline that exists today may vanish a million years later beneath fresh lava. A mountain range slowly appears where yesterday there was only flat ground. Entire valleys fill with cooling basalt. Yet despite all this change, there is a surprising sense of calm. Time moves so slowly that even great eruptions become gentle events within the rhythm of billions of years. If you remain still, listening carefully, you can almost hear the planet breathing. A soft rumble beneath distant mountains, steam whispering into cool air, rain tapping across newly formed stone, waves quietly meeting black volcanic shores. This is the sound of a world preparing itself, not for tomorrow, not for the next century, hidden within warm pools, along mineral-rich coastlines, and near gentle hydrothermal vents beneath the sea. The ingredients delivered by countless volcanoes are beginning to meet one another, ready for the quiet chemistry that will soon transform an empty planet forever. Now, allow your attention to rise once more, above the warm oceans, above the sleeping volcanoes, into the vast skies of the early Earth. The clouds have been gathering all day. Warm water from the newborn seas rises gently into the atmosphere. It cools. It condenses, layer upon layer. The clouds become taller, darker, heavier. Soon, the entire horizon is wrapped in towering storm clouds. They are unlike the storms we know today. The young atmosphere contains more heat, more moisture, more energy. These ancient tempests can stretch for hundreds of miles, moving slowly across an empty planet where nothing yet watches their arrival. There are no birds seeking shelter, no villages closing their doors, no ships turning towards safe harbor, only the quiet earth, waiting beneath an enormous sky. The wind begins almost unnoticed, a gentle movement across the water. Tiny ripples spread across the ancient sea. Steam drifts from warm volcanic shores. Clouds continue climbing higher until they reach the cold upper atmosphere. Inside those clouds, countless droplets of water, tiny ice crystals, and particles of volcanic ash collide with one another. Each gentle collision transfers a little electrical charge. One particle becomes slightly positive, another becomes slightly negative. Millions, then billions, of these tiny exchanges quietly unfold inside the growing storm. Eventually, the cloud becomes like a giant natural battery. The electrical imbalance grows stronger. The tension builds. Then, without warning, a brilliant flash races across the sky. Lightning, for just a heartbeat. The entire landscape glows with silver light. Dark mountains shine like polished glass. The restless ocean becomes a mirror. Clouds reveal their enormous towers. Then, the darkness gently returns. A few moments later, a deep rumble rolls across the empty world. Not frightening, almost comforting. A slow, gentle echo that fades into silence. Imagine floating peacefully above the sea, watching these storms from a safe distance. One flash appears on the horizon, then another. Soon, several storms dance across different parts of the planet. Earth has become a quiet theater of light. Every bolt carries extraordinary energy. For a fraction of a second, the air surrounding the lightning channel becomes hotter than the surface of the sun. Molecules that have remained stable for ages suddenly break apart. Atoms separate, then recombine into entirely new arrangements. Nature, without any intention, has opened another laboratory. Modern scientists have recreated similar conditions inside carefully controlled experiments. When simple gases, water vapor, methane, hydrogen, and ammonia are exposed to electrical sparks, something remarkable happens. Small organic molecules begin to form. Amino acids, simple compounds, tiny chemical building blocks that living things use today. Those experiments do not create life itself, but they demonstrate something beautiful. The ingredients for life do not necessarily require magic. Sometimes, given energy, water, time, and the right conditions, chemistry quietly discovers new possibilities all on its own. Now imagine that process happening, not inside a glass laboratory, but across an entire planet. Storm after storm, year after year, million after million of years. Every lightning strike becomes another opportunity. Most accomplish nothing lasting. Some create molecules that quickly disappear. Others leave behind tiny compounds that drift into rivers, warm ponds, or the vast oceans. Little by little, the chemical richness of the young Earth slowly increases. Rain joins the process once again. After every storm, gentle showers carry newly formed molecules toward the surface. Small streams gather them together. Rivers transport them across fresh volcanic rock. Eventually, almost everything finds its way back into the sea. The oceans quietly become richer than before, not with fish or seaweed, but with invisible ingredients, waiting patiently for their next encounter. Night falls. The storms continue. Lightning flickers far beyond the horizon. Reflections shimmer across calm water. Between each flash, the stars return, countless stars, brighter than those above modern cities. The Milky Way stretches overhead like a river of pale light. The moon, still much closer than it is today, bathes the landscape in soft silver. For a moment, the storms seem almost peaceful. The sky breathes with gentle rhythm. Flash, silence, a distant rumble, then quiet once more. Everything here is working together. The volcanoes provide minerals. The oceans gather them. The atmosphere protects warmth. The storms provide energy. None of these forces know what they are preparing. Yet together, they are slowly creating one of the most extraordinary moments in cosmic history. Because somewhere, perhaps inside a warm tidal pool, perhaps near a volcanic shoreline, or perhaps beside a quiet hydrothermal vent beneath the sea, thousands of tiny organic molecules are beginning to collect. They cannot see. They cannot think. They are not alive. But each gentle collision brings new combinations, new shapes, new possibilities, and somewhere within those countless invisible encounters, the long journey toward the very first living cell has quietly begun. Take one more slow breath. The storms have passed. The distant volcanoes glow softly along the horizon. Above, the ancient sky grows quiet once again. Now, let yourself sink gently beneath the surface of the newborn ocean. The sunlight fades little by little. Blue becomes green. Green slowly melts into darkness. The water grows cooler, calmer, almost perfectly still. Far below, the seafloor finally comes into view. It is unlike anything on modern beaches. There is no soft sand, no shells, no coral reefs, only endless fields of dark volcanic rock, freshly formed from Earth's restless interior. Everything here feels untouched, as though the planet has only just finished painting this hidden landscape. Tiny cracks weave across the ocean floor. From some of them, warm water quietly rises, not in violent explosions, but in slow, steady streams. These are the first hydrothermal vents, natural springs powered by the heat still stored deep inside the earth. Imagine drifting beside one of them. The surrounding water is cold, almost freezing, yet only a few feet away. A shimmering column of warm water flows upward like smoke beneath the sea. The water carries something precious. Not gold, not silver, but something even more valuable for the story about to unfold. Minerals, iron, sulfur, magnesium, calcium, phosphorus, tiny particles dissolved within the warm water, invisible to the eye, yet destined to shape every future living cell. As the warm water meets the colder ocean, those minerals slowly settle. Some form delicate crystals, others coat nearby rocks with thin, colorful layers. Over countless centuries, entire towers begin to grow. Stone chimneys, slowly built by flowing minerals. Some rise several stories above the seafloor. Others remain small, hidden among dark volcanic ridges. No fish swim between them. No crabs explore their surfaces. No giant squid drift through the darkness. This is a world before animals, before plants, before even the smallest microbe. Only warm water, ancient rock, and quiet chemistry. If you listen carefully, there is almost no sound, only the gentle whisper of moving water, a faint crackle as minerals cool, the distant heartbeat of the earth, echoing through solid stone. Scientists today continue to discover remarkable life around hydrothermal vents. Entire communities flourish there without sunlight. Tiny bacteria draw energy directly from chemicals rising out of the Earth's interior. Tube worms, shrimp, crabs, and unusual fish all depend upon those microscopic pioneers. But billions of years ago, these communities do not yet exist. The vents are empty, and that emptiness is full of possibility. Many researchers believe places like these may have been ideal nurseries for life's earliest chemistry, not because they contained life already, but because they offered something rare: a steady source of heat, fresh minerals, natural chambers within porous rocks, and constant chemical gradients. Imagine millions of tiny pockets inside those mineral chimneys, each one no larger than a grain of sand. Warm water flows through them endlessly. New molecules drift inside, others drift away. It is almost like a vast natural laboratory, with countless tiny rooms, each quietly running its own experiment. No one designed these chambers. No one planned them. They simply formed, because water met rock, again and again, for millions of years. Inside those microscopic spaces, certain molecules linger a little longer. Some attach themselves to mineral surfaces. Iron and sulfur atoms help move tiny amounts of energy from one reaction to another. Clay minerals nearby provide flat surfaces where simple compounds can gather instead of floating endlessly apart. Each step seems impossibly small. Nothing here resembles life. There are no cells, no DNA, no heartbeat, and yet, the distance between chemistry and biology is becoming just a little shorter, one tiny reaction at a time. Imagine drifting through this silent underwater landscape for an entire day. Nothing dramatic happens. No sudden miracle appears. Only patient repetition. Warm water rises. Minerals circulate. Molecules meet. Separate. Then meet again. Nature is wonderfully persistent. It never becomes discouraged. It never grows tired. Given enough time, even the smallest possibilities are explored, and time is something this young planet possesses in extraordinary abundance. Millions of years pass like gentle waves. The mineral chimneys continue growing. The oceans continue mixing. The volcanoes continue feeding the sea with fresh ingredients. Every process supports another, like musicians quietly joining an orchestra long before the audience arrives. If you look upward, far above the dark ocean floor, the faint glow of sunlight filters through miles of water. It seems impossibly distant. Yet down here, life may not need sunlight at first. The Earth itself is providing energy. The planet has become both home and helper, a patient companion preparing the stage for its first tiny resident. So remain here for just another peaceful moment, floating effortlessly beside these ancient underwater springs. Listen to the warm water rising through stone. Watch invisible minerals swirl gently into the darkness, and know that somewhere within these quiet currents, the ingredients of life are becoming just a little more organized, ready for the next chapter, where simple molecules will begin finding one another, and the first whispers of true biological chemistry will quietly emerge. Take a slow, easy breath. Our journey has carried us through ancient oceans, across volcanic landscapes, beneath skies filled with lightning, and into the quiet darkness surrounding Earth's first hydrothermal vents. Now, something almost invisible is beginning to happen. Nothing dramatic, nothing that would catch the eye. If someone could somehow visit this world, they would see only water, rock, steam, and endless time, yet hidden within every drop of water. An extraordinary story is quietly unfolding. Imagine shrinking, smaller than a grain of sand, smaller than a single speck of dust. Smaller still, until the entire ocean surrounds you like an endless universe. Here, the water is no longer empty. It is filled with tiny molecules, each one drifting peacefully with the currents. Some are simple, a water molecule, just two hydrogen atoms gently holding onto one oxygen atom. Others contain carbon. Some carry nitrogen, others sulfur. Each molecule is remarkably small, yet together, they possess enormous potential. Carbon is especially fascinating. Scientists sometimes call it the backbone of life. Unlike many other elements, carbon enjoys making connections. One carbon atom can join another, then another. It can build long chains, tiny rings, delicate branches, almost like nature's own construction toy. That flexibility makes carbon perfect for creating complex chemistry. And complex chemistry will eventually become biology. As warm water circulates through volcanic rock, fresh carbon compounds continue entering the oceans. Some arrive from Earth's interior. Others form high in the atmosphere before rain gently carries them downward. Still others appear when lightning rearranges simple gases in the sky. The ocean slowly becomes richer, not crowded, not thick, just ever so slightly more interesting with each passing million years. Imagine millions upon millions of these tiny molecules floating together. Most simply drift past one another, meeting briefly, then continuing on their separate journeys. But every now and then, two happen to fit together. They bond. A new molecule is born. Sometimes it survives only moments before breaking apart again. Sometimes it remains stable for years, or centuries, or even longer. Nature does not become disappointed when a reaction fails. It simply tries again, and again, and again, across an entire planet. There are countless opportunities. Warm ponds near volcanic shores, quiet tidal pools, mineral-rich underwater vents, hidden cracks inside porous rocks. Every location becomes another workshop for chemistry. Some scientists imagine these ancient oceans as a vast soup. Not a thick soup, but a gentle mixture containing countless simple ingredients slowly mingling together. Others believe many important reactions happened on mineral surfaces, where molecules could gather more easily than they could while floating freely through open water. Both ideas may hold part of the truth. Earth offered many different environments, and nature was free to explore every one of them. Time remains the greatest advantage. A million years passes almost unnoticed. Then another million, then another 100 million. During that unimaginable span, tiny reactions continue without pause. Every sunrise adds fresh energy. Every rainfall stirs the oceans. Every volcanic eruption introduces new minerals. The entire planet has become a patient chemical workshop. Among the growing collection of molecules, some begin resembling ingredients familiar to modern biology. Simple amino acids, tiny fatty molecules, basic sugars, small nitrogen-rich compounds. These are not living things. Not yet. Think of them instead as letters scattered across a table. A single letter tells almost no story, but enough letters, given enough time, can someday form words, sentences, entire libraries. Life is much the same. Before cells, before DNA, before evolution, there first had to be an alphabet of chemistry. That alphabet is slowly assembling here. one molecule at a time, one quiet reaction after another. Perhaps the most beautiful part of this story is how ordinary the ingredients truly are. Hydrogen, carbon, oxygen, nitrogen, elements forged long ago inside ancient stars, long before our sun existed, long before Earth was born. The atoms floating through these young oceans are older than the planet itself. Some are older than our entire solar system. In a way, the universe has been preparing for this moment since the first generations of stars lit the cosmos. Now those ancient atoms finally meet one another, inside warm oceans on a quiet blue world. No celebration marks the occasion. No trumpet sounds. Only gentle waves rolling across empty seas. Tiny molecules drifting together. And endless patience. Somewhere, among trillions upon trillions of invisible encounters, a few molecules are beginning to organize themselves in slightly more complicated ways. Nothing alive has appeared, but the distance between simple chemistry and the first whisper of biology has become just a little shorter. And as the oceans continue their slow, peaceful dance, the tiniest building blocks of life quietly await the next chapter, where simple organic molecules will begin joining together into something far more remarkable than any one of them could become alone. Settle in once more. Let your breathing become slow, comfortable, unhurried. Our journey continues beneath the gentle surface of Earth's first oceans, where countless tiny molecules drift through warm water. Invisible, silent, patient, nothing living exists yet. Not a single cell, not a strand of DNA, not even the simplest bacterium. And yet, something extraordinary is quietly taking shape. Imagine watching a single drop of seawater. To your eyes, it would seem completely empty, but inside that tiny drop, millions upon millions of molecules are moving. They never stop. They gently bump into one another, separate, then meet again. Every collision offers a new possibility. Most encounters change nothing. Two molecules drift apart exactly as they arrived. Some combine briefly, only to separate moments later. But every now and then, a connection lasts. A new compound forms. It is small, simple, yet slightly more complex than either molecule alone. Across the entire planet, these tiny successes slowly accumulate. One becomes 10, 10 become thousands, thousands become trillions. No one notices. There is no applause. Nature simply continues her quiet work. Scientists call these compounds organic molecules. The word organic today often reminds us of farms or food, but in chemistry, it simply means molecules built primarily around carbon. Carbon's remarkable ability to link together allows nature to build astonishing complexity from simple beginnings. Among these early compounds, tiny amino acids begin to appear. These are the same kinds of molecules that, billions of years later, will become the building blocks of proteins. Elsewhere, simple sugars form, not the sweetness you stir into tea, but primitive carbohydrates capable of storing small amounts of energy. Nearby, fatty molecules quietly emerge. Each one has a remarkable property. One end enjoys water, the other avoids it. At first, that may sound unimportant, but one day, those humble molecules will help create the first cell membranes. For now, they simply drift with the current, waiting for their moment. Nitrogen-rich molecules appear as well. Some resemble pieces that future life will eventually use to build RNA and DNA. Scientists cannot say with certainty exactly where every one of these compounds first formed. Some may have appeared in shallow ponds warmed by the sun, others near volcanic coastlines. Many likely formed around hydrothermal vents deep beneath the sea. Perhaps some even arrived aboard tiny meteorites, carrying complex carbon compounds from space. It is entirely possible that Earth's chemistry received a little help from the wider universe. Tiny carbon-rich meteorites still fall to Earth today. When scientists examine some of these ancient space rocks, they often discover amino acids and other organic compounds inside them. Imagine that. The same kinds of molecular ingredients drifting both through Earth's young oceans and through the vast darkness between the stars. Perhaps, long before life appeared anywhere, the universe had already become surprisingly skilled at making the raw materials. Earth simply offered them a welcoming home. As millions of years quietly pass, the concentration of these molecules slowly increases in certain places. A warm tidal pool slowly evaporates beneath the ancient sun. Water disappears into the air, leaving dissolved compounds closer together than before. A fresh rainstorm arrives days later. The pool fills again. The molecules begin drifting once more. Then the cycle repeats. Dry, wet, warm, cool. Again and again. Each cycle gives chemistry another opportunity to explore new combinations. Nearby, waves gently wash across smooth volcanic rocks. Thin films of water briefly cover their surfaces before slowly retreating. Molecules become trapped together for just a little while. Sometimes, that extra closeness allows new reactions to occur. The rocks themselves become quiet partners in the story. Certain minerals gently encourage specific reactions, not because they intend to, but because their surfaces naturally help molecules line up in useful ways. It is almost as though the Earth itself has become a patient teacher, offering countless tiny classrooms where chemistry can quietly practice. Nothing is wasted. Even failed reactions leave behind useful ingredients for future attempts. Nature never views failure the way humans sometimes do. Every ending simply becomes the beginning of something else. Every broken molecule becomes raw material once again. Across hundreds of millions of years, the oceans slowly become richer with invisible possibilities. Imagine floating above this peaceful world during sunset. Golden light stretches across gentle waves. Warm breezes move quietly over empty shorelines. No birds cross the sky. No footprints mark the sand. And yet, hidden beneath every ripple, the future is quietly assembling itself. The atoms that will someday build forests, whales, butterflies, dinosaurs, and human hearts are already here, still scattered, still incomplete, but no longer entirely alone. Some have begun finding one another. Some have begun working together. And somewhere, inside one quiet corner of this ancient world, a collection of simple molecules is becoming just a little more organized than before. Not alive, not yet, but moving one gentle step closer. The first true spark of life still lies ahead. For now, the oceans continue their patient rhythm. Waves rise, waves fall. Tiny molecules drift together beneath the surface. preparing for the remarkable moment when chemistry will begin behaving in a way that almost seems to remember itself. Take another slow breath. The young Earth continues to turn beneath the ancient sun. Gentle waves roll across newborn oceans. Volcanoes quietly release warmth into the sky. Rain falls, then clears, then falls once more. Across this peaceful world, there is no single place where life is destined to begin. Instead, the entire planet has become a vast collection of natural laboratories. Some lie beneath the open sky. Others remain hidden beneath miles of dark ocean. Each offers something unique. Each patiently explores its own possibilities. Imagine standing beside a warm tidal pool along an ancient volcanic shore. The tide has gently retreated. A shallow pool remains behind, only a few inches deep. The water is pleasantly warm from the rocks below. Tiny ripples shimmer beneath the hazy sunlight. Within this quiet pool, thousands of invisible molecules drift together. Unlike the open ocean, they cannot easily escape. As the day grows warmer, a little water slowly evaporates. The pool becomes slightly smaller. The molecules drift closer together. Some begin touching more often. Their chances of reacting quietly increase. Hours later, clouds gather overhead. Soft rain begins to fall. The pool fills once again. Fresh minerals wash in from nearby rocks. The molecules spread apart, only to repeat the entire cycle tomorrow. Wet, dry, warm, cool, again and again, for countless generations. Many scientists believe these repeating cycles may have helped increasingly complex molecules form. When water briefly disappeared, certain chemical bonds became easier to create. When the rain returned, those new molecules could spread, meet others, and continue changing. Nature never hurried. Each cycle was another gentle opportunity. Now, let us leave the shoreline behind. Drift back toward the sea, far beyond the waves. The ocean grows deeper. The sunlight gradually fades into soft green, then blue, then complete darkness. Here, near the hydrothermal vents we visited before, the conditions are very different. Instead of sunlight, the energy comes from Earth's interior. Warm, mineral-rich water pours continuously from rocky chimneys. Unlike the tidal pools, nothing here ever dries out. The chemistry never pauses. Fresh minerals arrive every moment. Warm water rises endlessly. Tiny chambers inside porous rocks protect delicate molecules from the powerful currents outside. Imagine one of those tiny chambers, smaller than the tip of a needle. Water slowly flows through it. New molecules drift inside. Others leave. Some remain trapped against mineral surfaces for days, years, or even longer. Within these natural pockets, complex chemistry has time to unfold. Some researchers believe these mineral chambers may have acted almost like tiny rooms, helping certain reactions happen more efficiently than they could in the open sea. Others suggest that shallow pools near coastlines offered the better environment. Perhaps both were important. The young Earth was filled with possibilities. Different locations may have contributed different pieces of the puzzle. There may never have been one single birthplace of life. Instead, many regions could have quietly cooperated across millions of years. One place forming simple molecules, another helping them grow more complex. Another protecting fragile structures long enough for something new to emerge. It is a beautiful thought, not one miracle, but countless ordinary places working together. Imagine watching this planet from space. Tiny coastlines sparkle beneath the sun. Deep oceans hide warm hydrothermal springs. Volcanoes continue building fresh islands. Storm clouds drift lazily across the atmosphere. Every environment offers something valuable: heat, water, minerals, energy, time. Each ingredient alone accomplishes very little. Together, they quietly transform an empty world into one that is becoming increasingly prepared for life. Meanwhile, the molecules themselves continue their patient dance. Fatty molecules begin gathering into tiny droplets. Simple chains of atoms occasionally become slightly longer. Some compounds become surprisingly stable. Others vanish almost as quickly as they appear. Nothing is permanent, yet nothing is wasted. Even when a molecule breaks apart, its pieces immediately become available for another attempt. Nature constantly recycles, always experimenting, always exploring, never discouraged. Hundreds of millions of years pass. The continents slowly drift. The oceans continue circulating. Fresh volcanic rock constantly renews the supply of minerals. The chemistry grows richer, not because of one dramatic event, but because the planet simply keeps going. Steady, patient, reliable. If you could pause this ancient world and look closely enough, you would see countless tiny droplets floating upon the water. Some made from fatty molecules that naturally arrange themselves into delicate spheres. Each one surrounds a tiny pocket of water. They are not alive, not even close, yet they possess something quietly remarkable. They have an inside and an outside, a simple boundary, a gentle separation from the surrounding ocean. That humble idea, a tiny compartment, will one day become one of the defining features of every living cell. For now, these fragile little bubbles drift peacefully with the currents. Most disappear within moments. Some survive a little longer. Each one hints at a future that has not yet arrived. The oceans continue whispering. Warm pools continue evaporating beneath the ancient sun. Deep vents continue breathing minerals into the sea. And somewhere, within one of these countless peaceful places, chemistry is becoming just a little more organized, preparing for the remarkable moment when simple molecules will begin storing information, and the long path toward the first true cell will quietly begin. Take another slow breath. The oceans continue their endless rhythm. Gentle waves rise, then quietly fall. The ancient earth has become a world filled with possibility. The ingredients are gathering. The tiny molecules are becoming more diverse. But one essential question still remains. Where does the energy come from? Because every living thing, from the smallest bacterium to the tallest redwood, to every human heartbeat, needs energy. Without it, nothing can grow, nothing can change, nothing can live. Long before the first cell appeared, the young Earth was already overflowing with sources of energy. Imagine standing once more on an empty volcanic shoreline. Morning sunlight slowly spreads across the sea. Its warmth touches the surface of every wave. Unlike today, the atmosphere contains almost no ozone. Powerful ultraviolet light reaches the ground with surprising strength. To modern life, that intense radiation would be dangerous. But for simple chemistry, it becomes another quiet gift. Each ray carries energy capable of rearranging atoms, breaking old bonds, creating new ones. Every sunrise becomes another day of gentle experimentation. Now, turn toward the distant mountains. Fresh lava glows softly beneath cooling rock. The earth itself radiates warmth. Heat escapes from below, not only through towering volcanoes, but also through countless cracks hidden across the planet. Every warm spring, every steaming shoreline, every hydrothermal vent offers another steady source of energy. Deep beneath the sea, something equally remarkable is happening. Warm water rich with hydrogen and other chemicals flows upward from Earth's interior. Nearby, cool ocean water carries oxygen-free minerals and dissolved carbon compounds. Where these different waters meet, natural chemical gradients are created. Think of them as tiny differences in energy, like water waiting behind a dam. Those differences may seem small, but nature has always been wonderfully skilled at using even the smallest opportunities. Billions of years later, every living cell on Earth still depends upon energy gradients remarkably similar in principle. Your own cells are quietly powered by tiny differences in charged particles moving across microscopic membranes. In a sense, life never abandoned one of its earliest lessons. The ancient Earth was already teaching it. Imagine floating beside a hydrothermal vent. Warm, mineral-rich water rises continuously. Invisible chemicals mingle with the surrounding sea. Every second, tiny reactions occur. Most leave no lasting trace. Others produce slightly more complex compounds. The chemistry never sleeps, even while the surface of the ocean rests beneath moonlight. These hidden laboratories continue working. Day and night become almost meaningless beneath the sea. The earth simply keeps breathing. Lightning still flashes overhead. Volcanoes continue erupting. The tides slowly rise and fall beneath the pull of the nearby moon. Every natural force contributes a little energy. No single source performs all the work. Instead, the planet becomes a network of countless gentle power stations, each one helping chemistry explore another path. If we could speed time forward, millions of years would pass in only moments. Storms would come and go. Mountains would slowly rise. Entire coastlines would quietly disappear beneath the sea. Yet through all those ages, energy never stops flowing. And that constant flow is one of the deepest rules of the universe. Life does not create energy. It learns to borrow it, to guide it, to use it wisely. Even today, every green leaf captures sunlight. Every ocean current carries heat. Every animal depends upon energy first gathered from its surroundings. The story begins here, long before the first living thing exists. Scientists often describe life as something that stays organized while everything around it tends toward disorder. That sounds almost mysterious, but perhaps it is easier to imagine a tiny water wheel placed inside a flowing stream. The water wheel does not create the moving water. It simply uses the flow. One day, the first living systems will do something very similar. They will not invent energy. They will simply learn how to guide it. That lesson begins in these quiet oceans. Picture millions of microscopic droplets drifting through warm water. Inside them, tiny chemical reactions occasionally become just a little more efficient. Not because anyone planned them, but because nature keeps testing new combinations. Again, and again, and again. Most disappear without leaving a trace. Some last a little longer. Every small improvement becomes another gentle step forward. Nothing here feels dramatic. No miracle suddenly transforms the planet. Instead, the universe continues doing what it has always done, allowing simple rules, given enough time, to create extraordinary complexity. The warm sun above, the restless earth below, the patient oceans between them. Together they provide everything chemistry needs to keep exploring. As evening slowly returns, golden light dances across the calm sea. The volcanoes glow softly against the fading sky. Warm springs continue flowing beneath the waves. Invisible molecules quietly exchange energy in the darkness. And somewhere, hidden inside one tiny corner of this ancient world, a remarkable pattern is beginning to emerge. Not a living cell, not yet, but a collection of molecules that can hold together, react together, and perhaps, just perhaps, prepare to do something no chemistry has ever done before. In our next chapter, those countless invisible experiments will continue until one of them begins to repeat itself, opening the first true doorway between ordinary chemistry and the earliest whisper of life. Take a slow, peaceful breath. The ancient earth continues its quiet rhythm. The oceans rise and fall beneath the pull of the nearby moon. Warm rain still falls upon dark volcanic shores. Deep beneath the sea, hydrothermal vents continue releasing heat and minerals into the water. Everything moves. Everything changes. Yet one question still remains unanswered. How does chemistry become life? The answer may begin with something wonderfully simple. Repetition. Imagine a single tiny molecule floating through the ancient ocean. It is not alive. It cannot think. It has no purpose. It simply exists. Most molecules remain exactly as they are until they eventually break apart. But every now and then, a very unusual molecule appears. One whose shape allows it to help create another copy of itself. Not perfectly, not every time, but often enough to matter. This is one of the most fascinating ideas in modern science. Before there could be living cells, there may have been molecules capable of making rough copies of themselves. Scientists call this self-replication. Today, every living thing depends upon it. Your own body contains trillions of cells. Each one inherited genetic information copied from earlier cells. That chain stretches backward, through every generation, all the way to life's earliest ancestors. But before DNA became life's great library, many researchers believe a simpler information-carrying molecule may have appeared first. A molecule known as RNA. RNA still exists inside every living cell today. It helps read genetic instructions, build proteins, and guide countless chemical reactions. Unlike DNA, RNA can do something especially remarkable. Certain forms of RNA can act both as information and as a simple chemical helper. In other words, it may have been able to store instructions, while also helping reactions take place. That unusual combination has led many scientists to imagine an ancient period called the RNA world. No one knows for certain whether it truly existed. The evidence is incomplete. Time has erased nearly every trace. Yet the idea remains one of the most compelling possibilities for life's earliest chapter. Imagine tiny RNA like molecules drifting through warm pools, or hidden within mineral chambers deep beneath the sea. Most quickly disappear, but occasionally, one survives long enough to encourage another similar molecule to form. The copy is not perfect. Perhaps one tiny piece changes. Sometimes that change makes the new molecule less stable. It soon falls apart. Other times, the small difference allows it to survive just a little longer, or to copy itself slightly more efficiently. Nothing is choosing these changes. There is no plan, no designer carefully selecting improvements. Only ordinary chemistry and chance. Yet chance, given enough time, can become astonishingly creative. Millions of years quietly pass. Countless molecules appear, disappear, and are replaced. Most leave no descendants. A precious few continue making imperfect copies. Those copies produce more copies. Very slowly, a simple form of evolution begins. Not among animals, not among plants, but among molecules themselves. Imagine sitting beside one quiet tidal pool during this immense span of time. To your eyes, nothing changes. The water gently shimmers beneath the ancient sun. Small waves lap against black volcanic rocks. The breeze carries the scent of warm stone and sea. Yet beneath the surface, an invisible drama unfolds. Tiny molecules are competing, not through violence, but through persistence. The ones that remain stable last longer. The ones that make copies become more common. The ones that fail quietly fade away. This is natural selection, in its gentlest and simplest form. Long before the first heartbeat, long before the first cell, nature has already begun discovering which chemical patterns can endure. Some scientists describe this moment as the bridge between chemistry and biology. The line is wonderfully blurry. There is no single instant when a lifeless molecule suddenly declares itself alive. Instead, life seems to emerge gradually. One small improvement after another, one successful copy after another. Like dawn replacing night, so slowly that no single moment marks the arrival of morning. Around these remarkable molecules, other compounds continue gathering. Fatty droplets drift through the water. Simple proteins begin appearing in small amounts. Minerals continue helping reactions along. The oceans have become increasingly rich with possibility. The ingredients are no longer isolated. They are beginning to cooperate. Some protect others. Some speed up reactions. Some carry information. Each new partnership makes the next discovery slightly more likely. The Earth has become a patient inventor, not rushing, never repeating exactly the same experiment twice, always exploring another possibility. Another combination, another quiet beginning, as another peaceful evening settles across the young planet. The stars appear overhead once again. Their light reflects gently across calm water. Below the surface, invisible molecules continue making imperfect copies of themselves. Most will disappear forever. A few will leave descendants. Those descendants will slowly become more capable, more organized, more resilient, and somewhere, perhaps inside a tiny fatty bubble drifting through warm water, one remarkable collection of molecules is beginning to stay together for just a little longer than before. Not yet alive, but closer than ever, closer than this planet has ever come. The next chapter will bring us to one of the greatest turning points in Earth's history, the quiet appearance of the first simple membrane. a fragile boundary that will separate the inside from the outside and prepare the way for the very first living cell. Take another slow, comfortable breath. The young Earth has waited a very long time for this moment. Hundreds of millions of years have passed. The oceans have mixed countless molecules together. Volcanoes have shared their minerals. Lightning has illuminated the skies. The warm sun has quietly powered endless chemical reactions. Now, something wonderfully simple begins to happen. Not life itself, not yet, but one small step that changes everything. Imagine a quiet tidal pool resting beneath the morning light. The water is calm. Tiny ripples sparkle across its surface. Nothing seems unusual, yet hidden within that peaceful water, millions of tiny fatty molecules continue drifting together. These unusual molecules have a curious shape. One end enjoys water. The other prefers to avoid it. Scientists call them amphiphilic molecules. They behave in ways that seem almost magical, though they follow nothing more than the ordinary laws of chemistry. As these molecules bump gently into one another, something remarkable happens. Without anyone arranging them, without any instructions, they begin organizing themselves. The water-loving ends naturally point outward. The water-avoiding ends quietly gather together, almost as though they are holding hands beneath the surface. Soon, tiny hollow spheres begin appearing, each one no larger than a microscopic bubble. Scientists today call structures like these vesicles. They form naturally under the right conditions. No life is required, only the simple properties of the molecules themselves. Imagine floating beside one of these invisible bubbles. Its delicate outer layer is astonishingly thin, only 2 molecules thick. Yet that fragile boundary creates something entirely new. For the first time, there is an inside and an outside. It may sound like a small difference, but it changes everything. Inside the tiny bubble, certain molecules become trapped together. Outside, the rest of the ocean continues drifting by. At last, some chemical reactions can remain together long enough to grow more complex. Instead of immediately washing away, helpful molecules stay close to one another. It is almost like building the first tiny room inside an endless open field. Within that room, new possibilities quietly appear. The bubble itself is incredibly fragile. A gentle wave may tear it apart. A change in temperature may cause it to disappear. Yet the oceans contain countless trillions of these tiny spheres. If one breaks, another naturally forms nearby, again and again, across the entire planet. Nature does not depend upon a single success. It patiently creates opportunities without end. As millions of years continue passing, some bubbles become slightly more stable than others. Perhaps the surrounding water contains more minerals. Perhaps certain molecules strengthen the membrane. Perhaps the temperature remains just a little more gentle. No one knows exactly which path the earliest membranes followed. Several possibilities remain scientifically plausible, but nearly all of them begin with the same quiet idea: a simple boundary. Inside, outside, protection. Imagine now that one tiny RNA-like molecule drifts into one of these fragile bubbles. Soon afterward, another follows, then a small amino acid, then a few useful minerals. For the first time, these ingredients remain together instead of drifting endlessly apart. The tiny membrane has become a peaceful shelter. Inside this microscopic world, chemical reactions begin occurring more often, not because the molecules have become intelligent, but because they finally remain close enough to meet again. The little bubble almost resembles a tiny home, no larger than a speck invisible to every human eye. Yet within it, the first hints of organization quietly emerge. The membrane itself is never completely closed. Certain small molecules slip through naturally. Water moves gently in and out. Some nutrients enter. Other compounds leave. The tiny sphere is already exchanging materials with the world around it. In that sense, even these primitive structures begin interacting with their environment. A beautiful relationship quietly develops. The ancient oceans provide raw materials. The membrane gathers them together. Chemistry becomes slightly more organized. Every successful reaction makes another one just a little more likely. Picture millions of these tiny bubbles drifting peacefully across the warm sea. Most survive only briefly. Some last longer. A very small number accidentally trap combinations of molecules that work especially well together. No miracle announces their arrival. No sudden flash changes the planet. Instead, nature gently whispers. One tiny improvement, followed by another, then another. The line between chemistry and biology grows softer with every passing age. If you were somehow watching this ancient world from above, nothing would appear different. The oceans still shimmer beneath the sun. Volcanoes still breathe into the sky. Rain still falls upon silent shores. Yet beneath every wave, the future of Earth has quietly taken one enormous step forward. Because for the first time, tiny chemical systems possess something every future living creature will inherit. A place to call their own. A protective boundary. A tiny home where life's earliest experiments can continue. And somewhere, inside one especially fortunate little membrane, the ingredients are beginning to work together with surprising harmony. The moment is drawing closer. Very soon, one fragile bubble will cross an invisible threshold and become something the universe has never seen before. The very first living cell. Take one slow, peaceful breath and let your imagination become wonderfully small, smaller than a grain of sand, smaller than a single droplet of mist, smaller than anything your eyes could ever hope to see, far beneath the quiet surface of Earth's ancient oceans. A tiny membrane drifts gently with the current. From the outside, it looks no different from countless other microscopic bubbles. The waves pay it no attention. The volcanoes know nothing of its existence. The stars above continue their silent journey across the sky. And yet, inside this tiny sphere, something extraordinary is quietly unfolding. Within its delicate membrane, helpful molecules have gathered together. Simple RNA-like molecules, tiny proteins, minerals, water, and countless chemical companions that have spent millions of years searching for one another. The membrane keeps them close enough to interact. Again and again, each reaction leaves behind another opportunity, another possibility. Most tiny bubbles eventually disappear. Their membranes break apart. Their contents return to the ocean. The experiment quietly ends. But this particular little bubble, holds together just a little longer, long enough for something remarkable to happen. Inside, certain molecules begin helping produce more of themselves. Not perfectly, not quickly, but consistently enough that the tiny system continues existing instead of falling apart. For perhaps the first time on Earth, a chemical system is beginning to maintain itself. Scientists sometimes describe one of life's defining qualities as self-maintenance. Living things are constantly repairing themselves, replacing worn-out parts, keeping order inside while the world outside remains in constant change. This little structure is only taking the very first steps along that path. It is incredibly simple, nothing like even the smallest modern bacterium. It has no nucleus, no complicated machinery, no elegant DNA packed inside chromosomes. Those wonders belong to a much later chapter. This pioneer is astonishingly humble, yet it possesses something profoundly important. It can remain separate from its surroundings, while carrying out simple chemistry inside. Imagine watching this microscopic world. Tiny molecules drift toward the membrane. Some slip through naturally, others remain outside. Inside, gentle reactions continue. Waste products slowly leave. Fresh materials quietly arrive. The tiny bubble has begun exchanging matter with its environment. In the simplest possible way, it is interacting with the world. The surrounding ocean becomes both its home and its source of nourishment. It borrows materials, borrows energy, borrows time. Nothing belongs entirely to the little cell. Everything flows. Everything circulates, just as it still does inside every living creature today. Modern cells perform this same quiet dance every second. They continuously exchange materials with the world around them. They are never truly isolated. Even your own body, with its trillions of cells, depends upon this endless conversation with the environment. The first cell quietly began that conversation billions of years ago. No one witnessed its arrival. There were no forests whispering nearby, no animals taking notice, no mountains celebrating, only the gentle movement of ancient water beneath an unfamiliar sky. Scientists cannot point to one exact moment when chemistry officially became biology. There is no universal agreement. Life emerged gradually, like the first hints of dawn slowly replacing darkness. At some point, without anyone noticing, the balance quietly shifted. A collection of molecules stopped behaving like ordinary chemistry and began behaving like something alive. That invisible threshold may have been crossed by countless tiny systems before one finally endured. Perhaps many early versions appeared, then vanished. Perhaps life began several times, with only one lineage surviving. The rocks have kept those secrets for nearly 4 billion years. What matters most is that one tiny family of cells continued, generation after generation, without interruption. That unbroken chain has never ended. Imagine that astonishing thought. Every bird flying through today's skies, every whale swimming beneath modern oceans, every towering redwood, every flower opening beneath the morning sun, every human heart beating quietly in the night, can trace its ancestry back through an unbroken sequence of living cells to pioneers very much like this one. The chain has never been broken, not once, for almost 4 billion years. Your own existence depends upon every generation successfully passing life forward. A journey so long, it almost escapes imagination. The first cell itself would seem almost invisible beneath the microscope used by many scientists today. Yet within that tiny space, The future of Earth quietly rested. It carried no knowledge of dinosaurs, no dreams of forests, no awareness of humanity. It simply continued doing the only thing it knew, maintaining itself, gathering energy, repairing tiny imperfections, preparing, without knowing it, for the next generation. As millions of years continue passing, more cells like it gradually appear, not suddenly, not everywhere, only here and there, across scattered corners of the ancient world, each one small, fragile, simple. Yet together, they represent the greatest transformation our planet has ever experienced. The Earth is no longer an empty world. It is now, very quietly, a living planet. The oceans continue whispering beneath the ancient moon. Warm currents carry these microscopic pioneers across the sea, invisible to everything, yet destined to reshape the atmosphere, the continents, and the future of every living thing still to come. In our next chapter, these tiny pioneers will discover new ways to gather energy from their surroundings, beginning the slow and beautiful journey toward a world filled with life. Take another slow breath. The first tiny cells now drift quietly through the ancient seas. They are almost unimaginably small. If thousands of them rested side by side, they could fit across the width of a single grain of sand. Yet inside each one, a quiet miracle continues. It is alive, not in the rich, complicated way that life exists today, but alive nonetheless. Its greatest challenge is simple. How can it continue living? Every tiny repair, every copied molecule, every gentle movement inside the cell requires energy. Without a constant supply, life quickly comes to an end. The earliest cells have no leaves to capture sunlight, no roots reaching into soil, no lungs, no eyes, no muscles. They survive in wonderfully simple ways. Imagine one of these ancient pioneers floating near a warm hydrothermal vent. Mineral-rich water flows gently around it. Hidden within that water are small chemical compounds: hydrogen, iron, sulfur, methane, simple substances created naturally by the young Earth. The little cell discovers something remarkable. Certain chemicals contain stored energy. If it can carefully rearrange those chemicals, a tiny amount of that energy becomes available, not through fire, not through combustion, but through elegant chemical reactions taking place inside the cell. Today, scientists call this chemosynthesis. Many modern microbes still live exactly this way, deep beneath the oceans, far beyond the reach of sunlight. Entire communities survive using chemical energy released from hydrothermal vents. In a sense, they preserve one of Earth's oldest traditions. Imagine watching these tiny cells beneath the microscope. A molecule of hydrogen drifts through the membrane. Inside, special proteins help guide a series of gentle reactions. Energy is released in carefully controlled steps. Nothing is wasted. The cell stores a little of that energy for later, enough to repair its membrane, enough to build another useful molecule, enough to continue existing one more day. It is astonishingly efficient. Even modern technology struggles to match the quiet elegance of life's chemistry. Every living organism on Earth, including you, still uses tiny molecular machines that guide energy through carefully organized pathways. The details have become far more sophisticated, but the basic idea began here. The first cells also learn another important lesson. Energy is rarely abundant. Sometimes nutrients drift by in great numbers. Other times, the surrounding water becomes nearly empty. Those tiny pioneers must patiently wait. Imagine one little cell drifting through a calm stretch of ocean. For hours, perhaps days, very few useful molecules pass nearby. The cell slows its internal activity. It conserves energy. It repairs only what is necessary. It waits. Then, a gentle current arrives. Fresh minerals and chemical compounds surround it once again. Immediately, its quiet chemistry resumes. Even today, countless bacteria survive this way. When food becomes scarce, they simply become less active, patiently waiting for better conditions. Life's earliest teachers were incredibly practical. Waste nothing. Use only what you need. Remain patient. Wait for opportunity. These lessons have echoed through billions of years of evolution. Picture thousands of these primitive cells drifting together, not because they seek companionship, only because ocean currents gently carry them along the same path. Some settle briefly upon mineral-rich rocks. Others remain suspended in open water. Each tiny cell quietly solves the same daily puzzle. Gather energy, maintain itself, repair tiny damage, continue living. No grand ambitions, no future plans, only the peaceful rhythm of survival. Meanwhile, the Earth itself continues changing. Volcanoes still shape the continents. Storms still cross the oceans. The moon slowly moves farther away from Earth, though far too slowly for any cell to notice. Time continues flowing. Millions of years pass like gentle waves. With every generation, tiny changes appear. Some cells become slightly better at gathering energy. Others become more efficient at repairing themselves. Some survive difficult conditions more successfully than their neighbors. Little by little, natural selection quietly rewards these improvements. There is no finish line, only continuous refinement, like a musician practicing the same gentle melody, growing slightly better each day. One remarkable innovation quietly appears. Some cells begin using natural chemical gradients across their membranes more effectively. Tiny charged particles gather on one side of the membrane. When allowed to flow back across, they release energy. Modern biology still depends upon this astonishing mechanism. Every one of your body's trillions of cells creates these tiny gradients every second. Your brain, your heart, your muscles, even while you sleep, all rely upon this invisible flow. The first cells discovered one of life's greatest inventions, and evolution never abandoned it. Imagine that. Your heartbeat tonight still carries a faint echo of chemistry first explored nearly 4 billion years ago. The connection is unbroken. Generation after generation, life has carefully preserved what worked. As another peaceful sunset spreads across the ancient Earth, the little cells continue drifting beneath gentle waves. Invisible, silent, patient, they have learned how to borrow energy from their surroundings. Not perfectly, but well enough to endure. And endurance is exactly what the future requires. For the next great milestone is approaching. Soon, one tiny cell will accomplish something every living creature depends upon. It will divide, not simply growing larger, but becoming two, beginning a family tree that will never truly end. And with that quiet moment, Life's long story will begin spreading across the earth. Take another slow breath. The ancient ocean is calm. Soft waves drift across the surface, while far below, tiny living cells continue their quiet existence. They have learned to gather energy. They have learned to repair themselves. Now, life is about to discover something even more extraordinary: how to continue beyond a single lifetime. Imagine one tiny cell floating peacefully through warm water. It has gathered enough nutrients. Its membrane is strong. Its internal chemistry remains stable. Little by little, it grows. Not quickly. There is no rush. Every useful molecule becomes part of the little cell. Its membrane gently stretches. Its tiny collection of genetic instructions is carefully copied. Not perfectly, but carefully enough. Today, every living cell on Earth follows a similar principle. Before a cell divides, it must first copy its genetic information. Those first primitive cells almost certainly did this in a far simpler way than modern organisms. Yet the purpose was already the same: to pass life's instructions forward. Imagine watching through an impossible microscope. Inside the little cell, molecules quietly organize themselves. The copied genetic material slowly separates. The membrane begins narrowing in the middle, almost like someone gently tying a ribbon around a tiny balloon. The narrowing continues. Very slowly, the connection becomes thinner and thinner. Then, without drama, the membrane quietly closes. One cell has become two. There is no celebration, no sound, no flash of light. Only two tiny pioneers, drifting gently apart beneath the ancient sea. Both continue living. Both continue gathering energy. Both carry nearly the same instructions. Life has just discovered reproduction. It is difficult to overstate how important this quiet moment is. Before now, every successful chemical system eventually disappeared. No matter how stable, its story always ended. But now, the story continues. One generation gives rise to another. The chain no longer depends upon a single fragile cell. It begins extending into the future. Imagine dropping one tiny pebble into a perfectly still pond. Ripples spread outward in every direction. Cell division is much the same. One becomes two. Two become four. Four become eight. Eight becomes 16. The numbers grow slowly at first, then astonishingly fast. Provided enough nutrients remain available, a single successful lineage can eventually produce countless descendants. Of course, the process is far from perfect. Mistakes sometimes occur while copying genetic information. Most changes accomplish nothing useful. Some make the new cell less capable. Those lineages quietly disappear. But every so often, a tiny change proves helpful. Perhaps one cell gathers nutrients slightly faster. Perhaps another repairs its membrane more efficiently. Perhaps one survives warmer water or stronger currents. Those tiny advantages accumulate, generation after generation. Natural selection quietly begins shaping life. No one chooses the winners. The environment itself becomes the teacher. The cells best suited to their surroundings simply leave more descendants. Over unimaginable spans of time, small improvements slowly build upon one another. Picture a quiet stretch of shallow sea. Millions of tiny cells now drift through the water. They remain invisible to every eye. Yet the ocean is no longer empty. Life has begun spreading. Some cells settle briefly upon warm rocks. Others drift with gentle currents across entire coastlines. Some are carried deep into the open ocean. Each new location offers fresh opportunities, different temperatures, different minerals, different chemical conditions. The Earth itself becomes a vast classroom. Every new environment teaches life another lesson. Meanwhile, the generations continue. One cell divides. Its daughters divide again, then their descendants. The family tree grows without anyone noticing. Imagine tracing your own family backward. Parents, grandparents, great-grandparents. The generations seem endless. Now continue beyond humanity, beyond mammals, beyond dinosaurs, beyond fish, beyond the first animals, beyond the earliest complex cells, beyond everything familiar. Eventually, every branch converges. All life returns to these humble pioneers drifting through ancient oceans. You, every tree outside your window, every bird that has ever flown, every flower that has ever bloomed, all belong to one vast family. Its oldest ancestors were tiny cells much like these. The connection has never been broken. Even now, your own body contains cells dividing quietly every second. Skin cells, blood cells, cells lining your stomach, all performing a process inherited across nearly 4 billion years. The details have grown wonderfully sophisticated, yet the basic pattern remains beautifully familiar. Grow, copy, divide, continue, as the sun slowly sets once again over the young earth. Golden light stretches across peaceful waters. The first great families of life drift beneath the waves. Invisible, fragile, yet astonishingly successful. The planet has quietly crossed another threshold. Life no longer exists as isolated individuals. It now possesses continuity, a future, a lineage, and with every gentle division, the oceans become just a little more alive. In the next chapter, those tiny pioneers will spread farther than ever before, transforming scattered beginnings into vast populations, until millions become billions, beginning Earth's first truly living world. Take a slow, peaceful breath. The young Earth is no longer quite as empty as it once was. For billions of years, the oceans waited in silence. Now, hidden beneath every gentle wave, tiny lives drift quietly through the water, still invisible, still incredibly simple, yet growing steadily with every passing generation. Imagine looking into a single drop of seawater. Long ago, you might have found only a handful of living cells. Now, that same drop contains many more. One cell becomes two, two become four, four become hundreds, hundreds become millions. Not in a single day, not even within a single lifetime, but across millions of patient years. Life spreads the only way it knows. Quietly, imagine floating high above the ancient planet. The oceans seem unchanged. The waves still roll softly toward dark volcanic shores. Clouds drift lazily across the unfamiliar sky. Nothing dramatic catches your eye. And yet, almost every current now carries tiny travelers. The sea has become alive. These first communities are astonishingly small. Most spend their entire existence drifting wherever the water carries them. Ocean currents become invisible highways. Some cells remain close to warm coastlines. Others journey thousands of miles across the open sea. A few settle upon submerged rocks, forming thin living films across the ancient stone. The rocks themselves slowly change color, not because of minerals alone, but because countless microscopic organisms now rest upon their surfaces. Every new home offers another opportunity: a quiet bay, a warm tidal pool, a mineral-rich vent. Each location encourages different tiny improvements. Some cells become better suited to warm water. Others adapt to cooler seas. Some thrive near volcanic chemistry. Others prosper in calmer regions. Life has begun exploring, not through curiosity, but through simple survival. Generation after generation, natural selection quietly shapes these microscopic pioneers. Imagine listening to the ocean. You still hear only gentle waves. The tiny cells make no sound, no songs, no footsteps, no calls across the water. Yet their silent presence is gradually transforming the planet. Every successful generation leaves behind another. Each descendant carries tiny differences. Most changes remain unnoticed. A few quietly help. Those helpful changes slowly spread. The process is wonderfully gentle. No race, no competition as we often imagine it. Only countless tiny experiments unfolding across unimaginable spans of time. Meanwhile, the oceans themselves become richer with life. When one tiny cell reaches the end of its existence, its molecules return to the water. Other living cells borrow those same atoms. Nothing is wasted. Carbon continues its endless journey. Nitrogen circulates. Phosphorus changes hands again and again. The earliest ecosystems begin to appear. Simple, yet beautifully connected. One living thing now influences another. For the first time, Earth possesses a genuine biosphere, a thin living layer surrounding an ancient world. It is almost impossible to see, yet it quietly blankets enormous stretches of the planet. Scientists estimate that life appeared surprisingly early in Earth's history. Evidence preserved within some of the oldest rocks suggests that microscopic organisms were already present more than 3.5 billion years ago. That means life established itself relatively soon after the planet became stable enough to support liquid water. Once it found a way to survive, it proved remarkably resilient. Imagine returning to one of the first cells we met several chapters ago. Its descendants now number beyond counting. Of course, the original individual disappeared long ago, but its family continues. Its genetic legacy flows unbroken through generation after generation. Like an endless river, every tiny division extends the story. Every successful copy strengthens the future. No cell knows it is making history. Each simply lives one quiet day at a time. Yet together, they are preparing a transformation greater than any mountain, any volcano, or any continent. Because these tiny pioneers will eventually change the chemistry of the oceans, then the atmosphere, then the climate itself. The Earth will never be the same. But for now, everything remains peaceful. The skies still contain almost no oxygen. The continents remain mostly barren. No plants decorate the shorelines. No animals stir beneath the waves. The age of microbes has only just begun. It will continue for well over 2 billion years, longer than all later plants, animals, dinosaurs, and humans combined. For most of Earth's history, The world belongs to these humble microscopic pioneers. And perhaps that is one of the most beautiful truths in science. The largest changes often begin with the smallest beginnings. A tiny cell, a quiet division, an invisible community, repeated patiently across the endless rhythm of deep time. As another ancient sunset paints the ocean with soft golden light, billions upon billions of microscopic lives drift peacefully beneath the waves, each one carrying forward the oldest tradition on Earth: to live, to divide, to continue. And somewhere among those countless descendants, a new kind of cell is slowly beginning to emerge, one that will learn an extraordinary new way to gather energy, not from chemicals beneath the sea, but from the gentle light of the ancient sun itself. That quiet discovery will one day fill the skies with oxygen and forever change the destiny of our living planet. Take a slow, gentle breath. The ancient Earth still looks almost unchanged. The continents remain dark and mostly barren. Volcanoes continue to glow beneath unfamiliar skies. The oceans stretch from horizon to horizon, peaceful, quiet, endless. If you could stand upon one of those empty shorelines, you might believe nothing important had happened. No forests sway in the breeze. No birds cross the sky. No fish leap from the waves. Everything appears calm. And yet, beneath the surface, the greatest revolution in Earth's history is already underway. Not with explosions, not with towering mountains, but with tiny living cells, so small that millions could gather on the tip of your finger. Imagine drifting once again into the ancient sea. Every drop of water now contains countless microscopic lives. Some float freely with the currents. Others cling gently to submerged rocks. Many gather in thin, nearly invisible films that coat the seafloor. The ocean is no longer simply water. It has become a living world. These tiny pioneers continue dividing, day after day, century after century, million after million of years. Each new generation quietly inherits the remarkable discoveries made by those before it. How to gather energy, how to repair a membrane, how to copy life's instructions, how to survive. The chain continues without interruption. Every successful division strengthens the future. Every surviving lineage becomes another branch on the growing tree of life. If we could speed time forward, the changes would become astonishing. 1,000 years pass, then 100,000, then 10 million. Still, the tiny cells continue their patient work. They ask for nothing more than water, energy, and time. Together, they slowly spread into nearly every environment the young Earth can offer. Warm coastal pools, deep volcanic vents, quiet lagoons, shallow seas, rocky shorelines. Every suitable place becomes another home. Each environment gently shapes its own communities. Some microbes flourish in warmth. Others tolerate cooler waters. Some prefer sulfur-rich chemistry. Others discover different ways to survive. Life begins quietly experimenting, not through intention, but through endless variation. Picture the ancient ocean at sunrise. Golden light spreads across gentle waves. Below, invisible billions begin another ordinary day. Each tiny cell quietly gathers nutrients, repairs itself, divides when conditions allow. Nothing dramatic happens. And that is precisely why this revolution is so extraordinary. Great transformations often arrive quietly. The slow growth of a forest, the steady carving of a canyon, the gradual movement of continents. Life belongs to that same gentle rhythm, patient, persistent, unstoppable. As the populations grow larger, the cells begin influencing one another in subtle ways. Some release chemical compounds into the surrounding water. Others benefit from those compounds. Simple relationships quietly emerge. One organism's waste becomes another organism's food. The earliest food webs begin taking shape. They are unimaginably simple compared to modern ecosystems. Yet the basic idea has appeared. Life is no longer existing as isolated individuals. It has become a community. The oceans themselves slowly begin changing. Not in color, not yet, but in chemistry. Every living cell takes certain molecules from the water. Every dying cell returns others. Over immense spans of time, these countless tiny exchanges begin leaving detectable fingerprints upon the planet. The rocks record them. Ancient sediments quietly preserve evidence of life's growing influence. Billions of years later, scientists will read those rocky pages, searching for the faint signatures left behind by these humble pioneers. Imagine how astonishing that truly is. Tiny cells, far too small for human eyes, quietly writing the first biological chapter in Earth's geological history. The planet itself becomes their diary, and that diary survives for almost 4 billion years. From high above, Earth still appears lonely. Blue oceans, dark land, clouds drifting peacefully overhead. But appearances can be wonderfully misleading. For the first time, our planet possesses something no telescope could easily detect: a biosphere, a thin living skin wrapped gently around a world of rock and water. It is fragile, yet remarkably resilient. No asteroid announces its arrival. No volcano stops erupting. The universe continues exactly as before. Only now, one small planet has begun carrying life. Perhaps somewhere else among the countless stars, the same quiet story has unfolded. Or perhaps, this tiny blue world remains wonderfully rare. We simply do not know. For now, we remain here, floating peacefully above Earth's ancient sea, watching the first great age of life unfold one invisible generation at a time. These humble microbes have no idea what lies ahead. They cannot imagine towering forests, swimming whales, flying birds, human voices, or quiet evenings like this one. Yet every one of those future wonders depends completely upon their patient work. The foundation has been laid. The story has begun. And somewhere among these countless microscopic pioneers, a remarkable innovation is slowly taking shape. A tiny group of cells is beginning to capture something even more abundant than chemical energy. The soft light of the ancient sun, that peaceful discovery, will one day transform the atmosphere itself and forever change the destiny of every living thing yet to come. Take a slow, comfortable breath. The first great chapter of life has quietly unfolded. The tiny pioneers have learned to survive. They have learned to gather energy. They have learned to divide, passing life's story from one generation to the next. Now, Earth enters an age unlike any other, an age that will last for more than 2 billion years, an age when almost every living thing on the planet is microscopic. Imagine floating above the ancient ocean once again. At first, everything appears exactly as before. The sea stretches endlessly toward the horizon. Clouds drift peacefully overhead. The distant volcanoes breathe gentle columns of steam into the quiet sky. But beneath the shimmering surface, the ocean is wonderfully different. Life is everywhere, not in great forests of seaweed, not in schools of fish, not in graceful whales. Instead, the water itself has become alive. Every handful of seawater contains countless tiny organisms, invisible travelers carried wherever the currents choose to lead them. Imagine shrinking until one single drop of seawater surrounds you. It no longer feels empty. Tiny cells drift slowly in every direction. Some travel alone. Others remain close together after dividing. They gently spin through the water, turning slowly with the smallest currents. There is no hurry. The ocean carries them with infinite patience. Some of these microbes spend their entire existence floating freely. Scientists today call such drifting organisms plankton. Even now, the modern oceans are filled with microscopic plankton. Every breath you take, every fish swimming beneath today's waves, depends upon these tiny floating communities. Their ancient ancestors began here, long before animals appeared, long before plants covered the land. The ocean currents become life's first highways. A gentle current may carry one tiny cell for hundreds of miles. Another may drift across an entire ocean basin over many generations. Some eventually settle onto submerged rocks. Others continue wandering beneath the open sky. No cell chooses its destination. The sea quietly decides. Imagine the sunlight filtering through the shallow water. Golden beams dance gently across the waves. Dust-like particles sparkle in the light. Among them drift countless microscopic lives. Each one follows its own quiet rhythm. Gather energy. Repair itself. Divide. Continue. Again and again. Some cells encounter warmer water near volcanic islands. Others drift into cooler regions farther from the equator. Some find nutrient-rich currents filled with dissolved minerals. Others survive long periods when resources become scarce. Every journey teaches life something new. Tiny differences slowly appear between distant populations, not because they intend to change, but because different environments quietly favor different strengths. The ocean itself becomes an invisible sculptor, patiently shaping the future. Imagine watching these journeys over millions of years. Entire generations drift across the sea without ever touching land. Their descendants continue the voyage. One family spreads eastward. Another travels west. A third settles near shallow coastal shelves. Life slowly explores every corner of the planet. The Earth has become wonderfully interconnected. A volcanic eruption releases fresh minerals into one region. Ocean currents slowly carry those nutrients across thousands of miles. Tiny microbes follow. The planet begins functioning as a single living system. Every current, every tide, every changing season now influences living communities. Although no seasons resemble those we know today, the rhythm of the Earth is becoming increasingly tied to the rhythm of life. If you pause for a moment and simply listen, the ocean remains beautifully quiet. No dolphins whistle beneath the waves. No seabirds call overhead. Only the soft movement of water. the distant murmur of volcanic islands, the whisper of gentle currents flowing across the ancient world. It is perhaps the quietest living planet that has ever existed. Yet beneath that silence, life is astonishingly busy. Every second, millions of tiny cells divide. Millions more quietly reach the end of their lives. Their atoms immediately return to the sea, ready to become part of another living cell. Nothing is wasted. Every carbon atom, every nitrogen atom, every phosphorus atom begins an endless journey from one organism to another. The first great nutrient cycles quietly emerge. These invisible cycles still sustain every ecosystem on Earth today. As evening slowly approaches, the sun sinks toward the horizon. Its golden reflection stretches across the peaceful sea. Below, countless microscopic pioneers continue drifting through the gentle currents. They know nothing of the future, nothing of forests, nothing of dinosaurs, nothing of humanity. Yet without their patient journey, none of those future wonders could ever appear. For now, they simply float, softly carried through Earth's ancient oceans. And somewhere among these immense microbial communities, some tiny cells are beginning to settle together upon rocky surfaces, building layered colonies that will slowly rise from the shallow sea, creating some of the oldest living structures our planet has ever known. Take another slow breath. The ancient sea is calm. Golden sunlight slips gently through the shallow water. Soft waves brush against dark volcanic shores. Beneath the surface, millions of tiny microbes continue drifting with the currents. Most remain travelers, but not all of them. Some discover something new. Instead of drifting forever, they settle. Imagine a single microscopic cell touching the surface of a smooth underwater rock. The rock has rested there for thousands of years. Warm, quiet, covered only by a thin film of minerals. The tiny cell gently attaches itself. It does not move again. Soon, another cell settles nearby. Then another, then dozens more. Each divides quietly. Each remains close to its neighbors. Before long, a delicate living carpet begins to spread across the ancient stone. Nothing about it appears impressive. It is only a paper-thin layer of microscopic life. Yet this simple gathering changes everything. The cells are no longer facing the world alone. Together, they begin helping one another. Some produce sticky substances that act like natural glue. Others trap tiny grains of sand carried by gentle currents. Fresh minerals settle onto the growing surface, layer upon layer. The colony slowly becomes thicker, year after year. The process continues. Imagine watching this place not for a single afternoon, but for 10,000 years. The colony grows only a few centimeters. 100,000 years later, it becomes slightly taller. After 1,000,000 years, the once flat rock now supports a rounded mound of living material. These are among the oldest living communities our planet has ever known. Scientists call many of these remarkable structures stromatolites. Even today, a few still survive in special places on Earth. They are living reminders of a world almost unimaginably ancient. Imagine placing your hand upon one of these gentle stone domes. Its surface feels slightly rough. Thin layers of tiny microbes quietly cover the outside. Below them lie countless older generations. Each layer records another chapter in the history of life. like pages in an ancient book, written one quiet season at a time. No architect designed these structures. No blueprint guided their growth. Every layer simply reflects the patient work of microscopic organisms, living, growing, capturing tiny particles, then making room for the next generation. The result is surprisingly beautiful. Some stromatolites resemble rounded pillows rising from the seafloor. Others form graceful columns reaching slowly upward toward the sunlight. Some grow into broad terraces, like miniature underwater landscapes. Each one is a city built by creatures too small to see. Imagine swimming gently above these ancient formations. The water is perfectly clear. Sunlight dances across the rippling surface overhead. Tiny currents carry fresh nutrients through the colonies. Every microscopic resident quietly performs its simple daily routine. Gather energy, repair itself, divide, continue. Alone, each cell accomplishes very little. Together, they slowly reshape the seafloor. Perhaps this is one of life's earliest lessons. Sometimes, working together creates possibilities that no individual could achieve alone. Long before animals formed herds, long before birds flew in flocks, long before humans built cities, these humble microbes had already discovered the quiet strength of community. Millions of years pass. The colonies continue growing. Storms occasionally cover them with thin layers of sand. The microbes patiently grow upward through the new sediment. Another layer forms, then another. The cycle repeats endlessly. Because of this steady rhythm, some stromatolites survive long enough to become preserved in stone. Billions of years later, scientists discover them inside some of Earth's oldest rocks. They stand as silent evidence that life had already flourished long before complex creatures ever appeared. Imagine how extraordinary that truly is. The oldest visible fossils on our planet were not giant animals, nor towering trees. They were peaceful microbial communities, patiently building gentle stone towers beneath shallow seas. Even today, when geologists find ancient stromatolites, they are reading messages written by some of Earth's earliest living inhabitants. Those quiet structures tell us, we were here, we lived, we endured. As another tranquil evening settles over the young world, the shallow lagoons glow beneath the fading sun. Rounded stromatolites cast soft shadows across the sandy seafloor. Gentle waves pass overhead. Tiny microbes continue their silent work, generation after generation. Without hurry, without pause, the earth is becoming increasingly alive. And among these ancient microbial cities, a remarkable new ability is quietly spreading. Some tiny cells are beginning to use sunlight in a far more powerful way than ever before. Not simply to survive, but to split water itself, releasing a gas that will slowly transform the oceans, then the atmosphere, and eventually, the destiny of every future living creature. That gas is oxygen. Take a slow, peaceful breath. The shallow seas are calm once again. Gentle waves glide across warm lagoons. The sun hangs low in the ancient sky, its golden light reaching down through clear water to the quiet microbial cities below. The stromatolites continue growing, not quickly, only a fraction of an inch over many years. Yet they never truly stop. Layer after layer, generation after generation, They patiently build upward. Imagine resting beside one of these living structures. Its rounded surface is covered with billions of tiny microbes. Each one is almost unimaginably small. Yet together, they are slowly changing something much larger than themselves. The rocks. Every day, fine grains of sand drift through the water. Tiny mineral particles settle gently onto the microbial mats. Rather than becoming buried, the microbes simply grow upward again. Their sticky outer layers trap another thin blanket of sediment. Soon, a fresh layer of living cells covers the new surface. Then another layer of minerals arrives. Then another layer of life. The cycle continues, again and again, over thousands of years. These quiet repetitions create structures that can stand several feet tall. They are not built in months or centuries, but over immense stretches of time. Nature works patiently. It never hurries. Imagine placing your hand upon the side of one ancient stromatolite. You would feel countless paper-thin layers stacked one above another. Each layer represents thousands of tiny lives, each one capturing a small moment in Earth's history. Together, they become living archives. Stone remembers when minerals slowly harden around these ancient colonies. The delicate layers become preserved long after the microbes themselves disappear. Their gentle architecture remains locked inside the rock. Billions of years later, scientists walk across deserts, mountain ranges, and windswept coastlines. Hidden inside certain ancient rocks, they discover these beautiful layered patterns. At first glance, they seem almost too simple. Rounded domes, gentle ripples, thin repeating bands. Yet those quiet shapes reveal something astonishing. Life was already here, long before animals, long before forests, long before even the first simple worm. These humble microbial communities left signatures that survived almost half the age of our planet. Imagine how extraordinary that truly is. The oldest cities on Earth were never built by humans. The oldest monuments were never carved from marble. They were patiently assembled by microscopic organisms, working together beneath shallow seas. Every layer whispers the same quiet message. We lived here. We grew. We endured. Meanwhile, the microbes are changing more than the rocks beneath them. As they gather nutrients, build new cells, and return materials to the ocean, they slowly alter the chemistry of the surrounding water. The changes are tiny, far too small to notice in a single lifetime, even over thousands of years. Almost nothing seems different, but over hundreds of millions of years, the effects become impossible to ignore. Imagine adding one single grain of sand to a beach each day. You would never notice the difference. Yet continue long enough, and an entirely new shoreline appears. Life changes the earth in much the same way, not through sudden transformation, but through endless gentle persistence. Every tiny cell contributes almost nothing alone. Together, they reshape an entire planet. The oceans gradually become more chemically balanced. Certain minerals grow less abundant. Others become more common. Iron drifting through seawater begins reacting with new substances produced by microbial life. Deep beneath the waves, thin layers of iron-rich sediments slowly settle onto the seafloor. Over immense spans of time, these layers harden into remarkable rock formations that modern geologists call banded iron formations. They appear as beautiful stripes of red, black, and gray, stretching across ancient cliffs. Today, many of the iron ores used to build bridges, railroads, and cities were formed during this quiet chapter of Earth's history. Imagine that. The steel in modern skyscrapers, the rails beneath speeding trains, even some of the metal inside everyday tools, may ultimately trace their origins back to chemical changes begun by tiny microbes nearly 4 billion years ago. The connection feels almost unbelievable, yet it is wonderfully real. Life and geology have become partners. The Earth shapes life. Life quietly reshapes the Earth. Neither works alone anymore. As evening approaches, soft orange light spreads across the peaceful lagoons. The stromatolites cast gentle shadows across the sandy bottom. Tiny waves ripple overhead. Billions of microscopic builders continue their patient work. They know nothing of the magnificent future they are creating. They simply grow, layer by layer, generation by generation, stone by stone. And somewhere within these peaceful microbial communities, a revolutionary new group is becoming increasingly successful. Tiny organisms that have learned to capture sunlight with extraordinary efficiency. Each day, without realizing it, they release a little more oxygen into the surrounding water. At first, the oceans quietly absorb it all, but not forever. One day, the balance will finally change, and the very air above the Earth will begin to transform. Take a slow, peaceful breath. Morning arrives once again on the ancient Earth. The sun rises gently above a quiet horizon. Its light spills across endless oceans, touching every ripple with soft shades of gold. For billions of years, that sunlight has warmed the planet. It has driven storms. It has powered countless chemical reactions. Yet most living cells have treated it as little more than part of the landscape. Now, a few remarkable pioneers are about to see the sun differently. Imagine drifting into a shallow lagoon. The water is calm and crystal clear. Rounded stromatolites rest quietly beneath the surface. Their living layers glow faintly beneath the morning light. Hidden among those countless microbes, a new kind of cell quietly goes about its day. It belongs to a group that modern scientists call cyanobacteria. Although they are often called blue-green algae, they are not algae at all. They are bacteria. Simple, ancient, and among the most important organisms that have ever lived. Imagine looking inside one tiny cyanobacterium. Instead of relying only on chemicals drifting through the water, it possesses delicate pigments that absorb sunlight. The most famous of these pigments is chlorophyll. When sunlight reaches the cell, those pigments capture tiny packets of energy called photons. Each photon carries only an unimaginably small amount of energy. Yet billions arrive every second. The little cell patiently gathers them, one after another. Nothing is wasted. Instead of allowing sunlight to simply warm the water, the cell begins using that energy to build food. Imagine a tiny solar-powered workshop, floating peacefully beneath the waves. The cell gathers carbon dioxide dissolved in the seawater. It draws in water from its surroundings. Then, using nothing but sunlight, it carefully rearranges those simple ingredients into energy-rich sugars. Food, created directly from light. Scientists call this astonishing process photosynthesis. Today, Almost every green plant performs it. Every forest, every meadow, every blade of grass, every giant tree. But the story began here, inside humble bacteria drifting through ancient seas. There is one small detail that changes everything. When these early cyanobacteria split water molecules apart, they produce something left over, a tiny waste product. The cell has no use for it, so it quietly releases it into the surrounding water. That waste product is oxygen. Imagine one little bubble of oxygen drifting away from a microbial colony. It seems completely unimportant, far too small to notice. The surrounding ocean immediately absorbs it. Iron dissolved in the seawater quickly reacts with the oxygen. The oxygen disappears almost as soon as it is created. Then another tiny bubble forms, and another, then another, for millions upon millions of years. The same quiet cycle continues. Countless cyanobacteria release oxygen every single day, yet almost none reaches the atmosphere. The oceans patiently absorb it all. Imagine standing on the ancient shoreline. You would notice nothing unusual. The sky remains hazy. The air still contains almost no oxygen. The world appears unchanged. But beneath the waves, a silent revolution has begun. The tiny cells have discovered an energy source greater than any chemical reaction: the sun itself. Think for a moment about how extraordinary that truly is. Nearly every meal ever eaten by every animal, every fruit, every grain of rice, every leaf, every forest, every breath of oxygen ultimately traces back to sunlight captured through photosynthesis. The chain begins here, with these quiet pioneers floating beneath an unfamiliar sky. As millions of years pass, cyanobacteria spread farther across the shallow seas. Their colonies become increasingly common. Stromatolites continue growing, now filled with sunlight harvesting microbes. Each morning, the rising sun powers billions of tiny chemical factories. Each evening, the work quietly pauses until dawn returns. The rhythm of day and night becomes woven into the rhythm of life itself. Sunrise, energy, growth, sunset, rest, again and again, across unimaginable ages. No organism understands what it is accomplishing. The cyanobacteria simply follow the chemistry that allows them to survive. They do not know they are transforming an entire planet. Yet with every passing generation, another tiny breath of oxygen enters the sea. Another invisible change quietly unfolds. The earth is beginning to inhale for the very first time. The oceans still keep most of that precious oxygen hidden, but they cannot do so forever. One day, the ancient seas will become full. The rocks will no longer absorb every molecule. And when that moment finally arrives, the sky itself will begin to change. The air above the earth will never be the same again. Take another slow, peaceful breath. The sun rises over the ancient earth once again. Its light spreads softly across quiet lagoons, touches the rounded tops of ancient stromatolites, and reaches deep into the shallow seas where billions of tiny cells begin another day. Nothing about the sunrise seems unusual. The sun has been rising for billions of years. But now, for the first time, life has learned to greet it in a completely new way. Imagine one tiny cyanobacterium resting near the surface of a stromatolite. It waits patiently through the darkness of night. Its chemistry slows. Its work becomes quiet. Then, the very first rays of morning arrive. Almost instantly, delicate green pigments inside the cell awaken. Tiny packets of sunlight, called photons, begin striking the chlorophyll molecules. Each photon carries only a tiny amount of energy, far too little to notice on its own. But billions arrive together. The little cell gathers them with astonishing precision. Imagine countless microscopic solar panels, each one catching another beam of ancient sunlight. Nothing is wasted. Every photon becomes another small gift, using that captured energy. The cell begins one of the most remarkable chemical processes ever discovered. It takes carbon dioxide dissolved in seawater. It draws in simple water molecules. Then, with the quiet help of sunlight, it rearranges those humble ingredients into tiny energy-rich sugars. The cell has made its own food. No hunting, no feeding, no swallowing. Only light, water, air, and patient chemistry. Today, every forest on Earth performs this same quiet miracle. Every meadow, every rainforest, every wheat field, every garden, every towering redwood, every blade of grass. Their green leaves are descendants of this ancient invention. Imagine watching the shallow lagoon throughout the day. Morning sunlight grows brighter. The cyanobacteria become increasingly active. Billions of microscopic cells quietly harvest light together. The lagoon almost resembles a vast underwater solar farm. Silent, gentle, beautiful. As the day continues, tiny bubbles begin appearing among the microbial mats. Each bubble contains a gas released as an unwanted byproduct of photosynthesis. The cells themselves have little use for it, so they simply allow it to drift away. Oxygen. At first, the bubbles disappear almost immediately. The surrounding seawater eagerly absorbs every molecule. Dissolved iron reacts with the oxygen. Ancient minerals consume it. The oceans still possess an enormous appetite. Imagine dropping a single raindrop into a dry desert. The ground drinks it instantly. For millions of years, the oceans behave much the same way. Every breath of oxygen released by cyanobacteria quickly vanishes into chemical reactions. Nothing reaches the sky, yet the tiny cells never stop. Day after day, year after year, million after million of years, they continue patiently filling an invisible reservoir. The oceans slowly become richer in oxygen, one tiny bubble at a time, one quiet sunrise after another. As evening approaches, the sunlight begins fading. The cyanobacteria gently slow their work. Night settles across the ancient world. The stars appear overhead. The moon reflects softly upon the peaceful sea. The microbial cities become quiet until dawn returns. Then, the entire rhythm begins again. Sunrise, photosynthesis, tiny bubbles of oxygen, sunset, rest. This gentle cycle repeats so many times that it becomes woven into the heartbeat of the planet itself. Imagine standing on the shoreline for a single day. You would notice almost nothing. Stand there for a century. Still very little. Remain for 1 million years. The changes remain subtle. But wait for hundreds of millions of years, and everything begins to change. Nature's greatest transformations are often almost invisible while they happen. A mountain slowly rises. A canyon slowly deepens. A forest slowly grows, and oxygen slowly fills a world. The cyanobacteria never understand what they are accomplishing. They do not know they are preparing the future. They cannot imagine birds filling the sky, or forests covering the continents, or mammals breathing air rich with oxygen. They simply follow the quiet chemistry that allows them to survive. And in doing so, they unknowingly prepare a home for every complex organism yet to come. Even tonight, as you quietly breathe, every breath carries oxygen whose story began with ancient pioneers much like these. The air filling your lungs can trace its history back through billions of years to quiet microbial communities resting beneath shallow seas. It is a beautiful connection. Ancient sunlight, captured by tiny bacteria, eventually becoming the breath of every animal that would ever live. As another peaceful dawn approaches the ancient earth, the work continues. The stromatolites glow softly beneath clear water. Countless cyanobacteria welcome the returning sun. Tiny bubbles of oxygen drift silently upward. Most still disappear into the waiting ocean. But not all. The seas are slowly reaching their limit. Soon, very soon in geological time, the oceans will no longer be able to hide every breath of oxygen. When that quiet moment arrives, the atmosphere itself will begin to change, and Earth will enter one of the greatest turning points in its entire history. The Great Oxygenation. Take another slow breath. The sun rises over the ancient Earth, just as it has for countless millions of years. Gentle waves shimmer beneath its light. The stromatolites quietly welcome another morning. Tiny cyanobacteria begin their daily work. Nothing seems different. And yet, the planet is approaching one of the greatest turning points in its entire history. For hundreds of millions of years, the oceans have patiently absorbed nearly every molecule of oxygen produced by photosynthesis. Iron dissolved in seawater eagerly captured it. Volcanic gases reacted with it. Ancient rocks quietly locked it away. The Earth behaved like an enormous sponge, soaking up every breath of oxygen life released. But no sponge can hold water forever. Imagine pouring one drop of rain into an empty bowl. It disappears, then another, and another. Eventually, the bowl begins to fill. One day, the next drop has nowhere to go. It gently spills over the edge. The oceans are reaching that moment. After unimaginable ages, much of the dissolved iron has already reacted. The ancient seas have slowly become saturated. Now, when tiny cyanobacteria release fresh oxygen, not every molecule disappears. Some remain dissolved in the water. Others begin drifting upward. Slowly, almost imperceptibly, the atmosphere receives its first lasting breaths of oxygen. Imagine standing upon a lonely volcanic shoreline. You would notice almost nothing. The sky still appears hazy. The air still feels unfamiliar. The change is far too small for any observer to detect. Yet every sunrise quietly adds another tiny breath, another invisible gift, another step toward a completely different world. Scientists call this remarkable chapter the Great Oxygenation Event. It began around 2.5 billion years ago, not over days, not over centuries, but across hundreds of millions of years. It was less like flipping a switch, and more like watching dawn slowly brighten the horizon. At first, only faint traces of oxygen entered the atmosphere. Then, Little by little, the concentration slowly increased. Imagine floating high above the Earth. From space, the planet still looks beautifully familiar. Blue oceans, dark continents, white clouds drifting peacefully overhead. Nothing dramatic reveals the revolution unfolding below. Sometimes, the greatest transformations happen where no eye can see them. Inside the air itself, inside the chemistry of the oceans, inside billions of tiny living cells quietly performing the same simple task every day. Capture sunlight, build food, release oxygen, again and again, across countless generations. For many early microbes, this new oxygen is not a gift. It is a challenge. Most ancient organisms evolved in a world without it. To them, oxygen is surprisingly reactive. Too much can damage delicate molecules inside their tiny cells. Many lineages slowly disappear. Others retreat into places where oxygen cannot easily reach. Even today, some descendants of those ancient microbes still thrive deep beneath the ocean floor, inside muddy wetlands, or buried beneath Earth's surface, living much as their ancestors once did. Yet a few remarkable organisms begin discovering something extraordinary. Instead of fearing oxygen, they learn to use it. Oxygen allows cells to release far more energy from food than older chemical pathways ever could. Imagine replacing the soft glow of a candle with the bright light of the morning sun. The difference is remarkable. Cells capable of using oxygen suddenly gain access to an entirely new level of energy. That additional energy will someday support larger cells, more complicated chemistry, eventually, entire multicellular organisms. But those distant futures remain unimaginable for now. For the moment, the Earth simply breathes a little differently than before. As oxygen slowly accumulates, another quiet transformation begins high above the clouds. Some oxygen molecules rise into the upper atmosphere. There, powerful sunlight gently reshapes them. 3 oxygen atoms join together, forming ozone. A thin, invisible shield slowly begins surrounding the planet. This ozone layer absorbs much of the sun's harmful ultraviolet radiation. For billions of years, Earth's surface had remained exposed to intense ultraviolet light. Now, a gentle protective blanket slowly appears. The planet is becoming safer for future life. Imagine that astonishing chain of events. Tiny bacteria drifting through shallow lagoons, quietly changing the chemistry of the oceans, transforming the atmosphere, creating an invisible shield high above the world, all without intention, all without knowing what they were accomplishing. The smallest organisms are quietly preparing a home for the largest ones that will one day follow. As evening settles once more across the ancient Earth, the stromatolites glow beneath the fading sunlight. Soft waves continue washing across peaceful shores. Above, the atmosphere carries just a little more oxygen than it did yesterday. Only a tiny amount, almost impossible to measure, yet enough to begin changing the destiny of an entire planet. The quiet revolution continues, one sunrise at a time, one tiny cell at a time, one invisible breath at a time, and in the ages still ahead, this transformed atmosphere will open the door to a completely new chapter of evolution, a world where larger, more complex, and more extraordinary forms of life can finally begin to emerge. take another slow, peaceful breath. The Earth has changed, not suddenly, not dramatically, but quietly, over hundreds of millions of years. If you could return to this ancient world after such an immense passage of time, you would notice something subtle. The sky feels different. It is still not the brilliant blue we know today. The air still carries volcanic gases. The continents remain mostly empty of visible life. And yet, an invisible transformation has begun. The atmosphere now contains something it has never truly held before. Oxygen. Only a small amount, far less than modern Earth, but enough to begin changing the planet forever. Imagine standing on a quiet shoreline just before sunrise. The sea is calm. Tiny waves whisper against dark rocks. The familiar stromatolites rest beneath shallow water, continuing the patient work they have carried out for ages. Above, the eastern horizon slowly brightens. As the first rays of sunlight reach the atmosphere, the sky glows with soft shades of amber, lavender, and pale gold. It is a peaceful morning, almost timeless. Yet every breath of wind carries molecules that were once impossible here. Each oxygen molecule has traveled an extraordinary journey. It began inside a microscopic cyanobacterium. It was released into the sea. It escaped into the air, then drifted freely around the planet. Imagine one tiny oxygen molecule floating high above the Earth. The winds carry it across oceans, over volcanic islands, across empty continents, around the entire globe. Eventually, sunlight reaches it, far above the clouds. Powerful ultraviolet light gently separates some oxygen molecules. The lonely oxygen atoms soon meet others nearby. 3 oxygen atoms join together. A new molecule is born. Ozone. Invisible, silent, yet profoundly important. Imagine millions upon millions of ozone molecules slowly gathering high in the atmosphere. They do not form a solid blanket, nor a visible cloud. Instead, they create a delicate shield, almost impossible to notice. Yet this thin layer quietly absorbs much of the sun's most energetic ultraviolet radiation. For billions of years, the surface of Earth had been exposed to that powerful light. Now, a gentle guardian begins taking shape overhead. The ozone layer grows slowly, patiently, just as everything else on this ancient planet has. Imagine standing beneath this changing sky. You feel nothing different. The sunlight remains warm. The breeze remains gentle. The waves continue their endless rhythm. Yet above your head, the atmosphere has become a safer place. Future generations of life will eventually explore shallow waters, then coastlines, then dry land itself. Much later, plants will spread across continents. Animals will follow. None of that would be possible without this quiet shield forming far above. The smallest organisms have unknowingly changed the future of every larger one. It is one of nature's most beautiful gifts. No reward was expected. No recognition was sought. The cyanobacteria simply lived according to their own simple chemistry. And in doing so, they transformed an entire world. Imagine watching Earth from space once more. The planet still appears peaceful. White clouds drift lazily across blue oceans. Dark continents rest beneath them. Nothing reveals the invisible atmosphere slowly becoming richer with oxygen. Sometimes, the greatest changes are those we cannot see. Think of your own body for a moment. You cannot see the oxygen entering your lungs. You cannot watch it travel through your blood. You cannot observe it reaching trillions of tiny cells. Yet every heartbeat depends upon it. Earth is experiencing something similar. The invisible has become essential. As oxygen slowly increases, life quietly discovers new possibilities. Some ancient microbes retreat into oxygen-free environments where their descendants still survive today. Others embrace this unfamiliar gas, learning to use it for remarkably efficient energy production. Those tiny pioneers will eventually give rise to every complex organism that follows. The future has quietly opened another door. As evening approaches, the sky deepens into gentle shades of violet. The first stars appear. The moon reflects softly across calm water. Far above, the young ozone layer continues its silent work. Below, the stromatolites remain unchanged. Their tiny builders know nothing of atmospheric chemistry, nothing of ultraviolet radiation, nothing of the extraordinary future they have made possible. They simply continue greeting each sunrise, harvesting light, and releasing one tiny breath of oxygen after another. The earth itself breathes more deeply with every passing age. And soon, this changing atmosphere will help trigger another remarkable chapter. A time when our peaceful blue world may become astonishingly cold, wrapped almost entirely in ice, before life quietly finds a way to endure once again. Take another slow, peaceful breath. The earth continues its gentle journey around the sun. The oceans still whisper against ancient shores. The cyanobacteria continue greeting each sunrise. The atmosphere slowly grows richer in oxygen. Everything seems to be moving toward a brighter future. Yet, nature rarely follows a perfectly straight path. Sometimes, even progress brings unexpected change. Imagine watching the earth from far above. The blue oceans remain beautiful. Clouds drift peacefully across the planet. The atmosphere is changing, but so is the climate. For billions of years, carbon dioxide has acted like a warm blanket around the young Earth. It trapped heat from the sun, keeping the oceans comfortably liquid. Without that blanket, the early planet might have frozen long ago. But now, something subtle begins to happen. The growing populations of photosynthetic microbes continue removing carbon dioxide from the atmosphere. Some use it to build their tiny bodies. Some becomes locked away in newly forming rocks. Meanwhile, oxygen continues increasing. Little by little, the balance of gases slowly shifts. The warm blanket becomes thinner. Imagine a chilly evening arriving just a little earlier each year. At first, no one would notice. The changes are almost impossibly small. Yet over millions of years, those tiny differences quietly add together. The planet slowly cools. Ice begins forming more easily near the poles. Bright white sheets spread gently across northern and southern seas. Unlike dark ocean water, ice reflects sunlight back into space. Instead of absorbing warmth, it sends much of it away. That reflection causes even more cooling, which creates even more ice. A beautiful, yet powerful, feedback begins. Imagine placing a white blanket over dark soil on a sunny day. The bright surface reflects much of the sunlight. The ground beneath remains cooler. The growing ice behaves in much the same way. As the frozen regions expand, they reflect more sunlight. The Earth cools a little further. More ice forms. The cycle quietly strengthens itself. Scientists believe that during parts of the Proterozoic Eon, our planet may have experienced extraordinary episodes of global freezing. Some researchers call this remarkable chapter Snowball Earth. The exact extent of the ice remains a topic of scientific study. Some evidence suggests glaciers may have reached almost to the equator. Other evidence supports a slightly less extreme world, with patches of open ocean still surviving. Either way, the planet became astonishingly cold. Imagine floating above the Earth during one of these frozen ages. White stretches across enormous portions of the globe. The oceans sparkle beneath thick ice. The continents wear brilliant coats of snow. The familiar blue world has become a quiet sphere of silver and white. Silence fills the landscape. The wind moves gently across frozen plains. Snowflakes drift softly through pale skies. The world feels peaceful, almost asleep. Yet beneath the ice, life quietly continues. The oceans do not become lifeless. Far below the frozen surface, liquid water still exists. Hydrothermal vents continue releasing warmth. Tiny microbial communities continue gathering energy. Photosynthetic organisms survive wherever sunlight can still reach the water. Sheltered coastal areas, thin ice, open patches of sea, these become quiet refuges. Life has learned an extraordinary lesson. Survival is not about avoiding every challenge. Sometimes, it is simply about enduring. Generation after generation, the tiny microbes continue living, dividing, waiting patiently. They have survived asteroid impacts, volcanic upheaval, changing atmospheres. Now, they survive a frozen world. Imagine one tiny cyanobacterium resting beneath clear ice. Above, the frozen surface glows softly in the pale sunlight. Below, the water remains calm. The little cell quietly performs photosynthesis whenever enough light filters through. Life slows, but it does not stop. Nature has become wonderfully resilient. Eventually, the same volcanoes that have shaped Earth since its youth continue releasing carbon dioxide into the atmosphere. Because so much of the planet is covered with ice, rainfall decreases. Less carbon dioxide becomes trapped in rocks. Gradually, the gas begins building up once again. The warm blanket slowly thickens. Millions of years pass. The ice begins retreating. Dark ocean water reappears. It absorbs sunlight once more. The warming accelerates. The frozen world gently awakens. Imagine standing on a shoreline as the first open waters return. Ice quietly breaks apart. Gentle waves once again touch ancient rocks. The sun reflects from liquid water instead of endless white. The earth breathes a little more deeply. Life emerges from its long winter, still carrying the same ancient determination that has guided it since the very first cell. Perhaps this is one of the quietest miracles in Earth's history. Not that the planet froze, but that life endured, patiently, without complaint, without surrender, waiting through millions of silent years until warmth returned. As another peaceful evening settles over the recovering earth, the last golden light glimmers across widening seas. The ancient microbes continue their quiet work. The atmosphere grows steadily richer with oxygen. The climate slowly stabilizes. and the stage is finally being prepared for another astonishing leap. Soon, some tiny cells will discover that living together can accomplish far more than living apart. From that quiet partnership, a completely new kind of life will emerge. The first complex cells, ancestors of every plant, every mushroom, every animal, and every human being yet to come. Take another slow, peaceful breath. The frozen ages have passed. The oceans once again shimmer beneath a warmer Sunday. The ancient skies carry more oxygen than ever before. The invisible ozone shield quietly protects the world above. For nearly 2 billion years, life has remained wonderfully simple. Tiny cells have filled the oceans. They have survived volcanoes, changing climates, and global ice. Yet every living thing still belongs to the same humble world of microbes. Now, something extraordinary is about to happen, not because life becomes larger overnight, but because it learns perhaps its greatest lesson of all. Sometimes, the best way to survive is together. Imagine one ordinary cell drifting peacefully through the sea. It gathers nutrients, repairs its membrane, divides quietly. Its daily life has changed very little for hundreds of millions of years. Nearby, another tiny cell drifts by. This one has discovered an unusually efficient way to use oxygen. It can release far more energy from food than many of its neighbors. The two cells meet. At first, it is only another chance encounter among trillions. One cell surrounds the other. Perhaps it intends to consume it. Perhaps it is simply another ordinary interaction. But something unexpected happens. The smaller cell is not digested. Instead, it survives inside its larger neighbor. Days pass, then weeks. Neither cell harms the other. Something remarkable begins to develop. The smaller cell continues producing energy. The larger cell offers protection, food, and a stable home. Both benefit. Scientists call this kind of relationship symbiosis. Two different living things, helping one another survive. Imagine sharing a quiet little house with someone whose skills perfectly complement your own. One prepares the meals, the other keeps the home warm. Neither could accomplish as much alone. Together, life becomes easier. That is exactly what begins happening inside these ancient cells. Generation after generation, the partnership continues. The energy-producing cell gradually loses its independence. It no longer needs to survive alone. Instead, it becomes a permanent resident. Over immense spans of time, the two separate organisms begin behaving as one. Today, every animal, every plant, every mushroom carries descendants of that ancient partnership. The tiny energy-producing guest still exists inside nearly all of your cells. Scientists call it the mitochondrion. Imagine that astonishing thought. Inside every heartbeat, inside every blink, inside every quiet breath you take, tiny descendants of ancient free living bacteria continue working tirelessly. They transform food into usable energy, exactly as their distant ancestors once did in Earth's early oceans. The partnership that began nearly 2 billion years ago has never ended. Some ancient cells eventually form another remarkable partnership. Instead of surrounding energy-producing bacteria, they welcome tiny photosynthetic bacteria. Those guests continue capturing sunlight. Over time, they become chloroplasts, The green structures inside every modern leaf, every tree, every blade of grass, every flower, every forest. Their story also begins with cooperation. Imagine floating through the quiet sea during this remarkable age. Most microbes continue living exactly as before. Simple, independent, successful. But here and there, a few unusual cells have become far larger than anything Earth has seen before. Inside them, different parts quietly specialize. Some produce energy, others manage genetic information, others transport nutrients. Life is becoming organized in entirely new ways. The cell itself has become a tiny community. Scientists call these remarkable organisms eukaryotic cells. Unlike the simple bacteria that came before, they contain specialized compartments. Their genetic material rests safely inside a nucleus. Tiny internal structures each perform different jobs. Everything has become more efficient, more coordinated, more capable. Imagine looking into one of these new cells through a magical microscope. It resembles a miniature city. Tiny highways transport materials. Energy stations quietly produce fuel. Protective membranes separate different tasks. Nothing is random. Everything works together. The complexity is breathtaking. Yet it all began with one peaceful partnership between two humble microbes. Nature once again teaches a gentle lesson. Progress does not always come through competition. Sometimes, the greatest breakthroughs emerge through cooperation. As millions of years quietly pass, these complex cells slowly spread across the oceans. They remain microscopic, still invisible to every human eye. Yet they carry possibilities unlike anything before them. With far more energy available, life can begin building larger bodies, longer cells. Eventually, groups of cells working together. The future suddenly becomes much wider. As another gentle sunset paints the recovering earth with soft gold, the oceans seem calm, almost unchanged, but hidden beneath the peaceful waves. The blueprint for every future animal, every towering tree, every colorful flower, and every human being has quietly begun taking shape. The smallest partnership in Earth's history will soon give rise to its greatest diversity of life, and the long wait for complex organisms is finally beginning to come to an end. Take another slow breath. The ancient oceans are peaceful once again. Gentle currents drift through warm, sunlit waters. Tiny complex cells now share the sea with the older microbes that came before them. Most of the world still belongs to microscopic life. Yet something quietly remarkable is beginning. Life is learning not only to cooperate inside a single cell, but between many cells. Imagine one newly evolved complex cell dividing. The two daughter cells separate, as they always have, but this time, they remain close together, not because they cannot drift apart, but because staying together offers a small advantage. One cell shares nutrients. Another helps anchor the tiny group to a rock. A third senses changes in the surrounding water. Each performs a slightly different task. Together, they accomplish more than any one cell could alone. No grand design guides this experiment. Nature is simply exploring another possibility. Some of these little colonies soon fall apart. Others remain together for many generations. Those that work will quietly endure. Imagine watching this process through countless millions of years. The tiny clusters slowly become more organized. Certain cells always remain on the outside. Others stay protected within the center. Some specialize in gathering food. Others focus on reproduction. Little by little, the first true multicellular organisms begin to emerge. They are wonderfully simple, nothing like the animals that will someday swim through the oceans. Nothing like the towering trees that will one day shade the land. Many resemble soft floating sheets, delicate strands, or tiny branching filaments swaying gently beneath the waves. The oceans are becoming more varied, more interesting, more alive. Imagine drifting slowly through one of these ancient seas. Soft sunlight filters down from above. Tiny colonies cling to submerged rocks. Simple algae wave gently with the currents. Microscopic organisms drift peacefully through the water. The world remains wonderfully quiet. Yet beneath that calm surface, evolution is exploring possibilities it has never known before. Some descendants of the ancient photosynthetic cells become the ancestors of algae. Their chloroplasts, inherited from long ago through ancient symbiosis, continue harvesting sunlight every day, generation after generation. Those descendants will eventually give rise to every green plant on Earth. Every moss, every fern, every flower, every towering forest, every leaf outside your window. Their story begins here. Other complex cells follow a different path. Instead of capturing sunlight, they gather food from their surroundings. Over time, some become the distant ancestors of animals. Not recognizable animals. Not yet. Only tiny soft-bodied organisms, living quietly beneath the waves. Still, the family tree has begun to branch. Imagine looking at the earth as though it were an enormous ancient tree. For billions of years, only a single sturdy trunk existed. Simple microbes. Now, tiny branches begin reaching outward. One will eventually become plants, another fungi, another animals. Many more will lead to countless forms of microscopic life still thriving today. Every branch begins from the same ancient root, the first living cells we visited so many chapters ago. Imagine how extraordinary that truly is. The oak tree standing beside a quiet country road, the blue whale crossing the Pacific Ocean, the hummingbird hovering above a flower, the mushrooms growing after autumn rain, and every human who has ever looked up at the stars, all belong to one vast family whose roots disappear into Earth's earliest oceans. As the oceans continue changing, the atmosphere grows steadily richer with oxygen. The protective ozone layer becomes stronger. The climate grows more stable. The planet feels increasingly welcoming. Life has spent billions of years patiently preparing its home. Now, that home is almost ready for something entirely new. Large bodies, moving creatures, eyes, mouths, muscles. None of those wonders exist yet, but the foundations are finally complete. The smallest builders have finished their work. Imagine the sun setting over the ancient sea. Golden light dances across calm water. Simple algae sway gently beneath the waves. Tiny multicellular organisms drift peacefully with the currents. The first ancestors of plants and animals quietly continue their ordinary lives. They have no idea what lies ahead. They cannot imagine forests stretching across continents, or coral reefs filled with brilliant fish, or birds singing at dawn. or human beings wondering where life began. They simply continue living, one peaceful generation after another, and with every passing million years, the stage grows more complete. The Earth has spent nearly 4 billion years preparing for the next great chapter. Soon, life will no longer remain hidden beneath microscopic scales. The world will awaken with astonishing speed, leading toward one of the most spectacular chapters in natural history, the great flowering of complex life, still waiting patiently, just beyond the horizon of deep time. Take one more slow breath. The ancient oceans are peaceful. The gentle currents continue their endless journey. The first ancestors of plants and animals quietly drift beneath the waves. Life has come an astonishing distance, from simple molecules to the first fragile cells, from lonely microbes to complex communities, from a world without oxygen to a planet slowly learning to breathe. And yet, one final lesson remains, perhaps the greatest lesson of all. Life is patient. Imagine standing upon an empty shoreline nearly 1 billion years ago. The air feels cleaner than ever before. The sky carries soft shades of blue that are becoming increasingly familiar. The sun rises over calm seas. Gentle waves roll toward land that is still almost completely barren. There are no forests, no flowers, no birds greeting the morning. The continents remain quiet. It would be easy to think that evolution has paused, but beneath the surface, life is still working, still experimenting, still waiting. Millions of years pass, then hundreds of millions more. The tiny multicellular organisms continue changing, almost too slowly to notice. Some become slightly larger. Others develop stronger connections between neighboring cells. A few discover entirely new ways of growing. Each improvement is wonderfully small, yet together, they quietly prepare the future. Imagine reading the longest book ever written. Not one page each day, but one page every 1,000 years. The story would seem almost motionless. Earth's history unfolds in much the same way. What appears still is often filled with quiet change. Deep beneath the sea, cells continue dividing. Genes continue changing. New partnerships quietly emerge. Old lineages fade away. Nothing stands completely still. Even when the world appears peaceful, the continents themselves continue drifting. Mountains slowly rise. Others quietly wear away beneath wind and rain. The moon moves a few centimeters farther from Earth each year. The length of a day becomes ever so slightly longer. The planet never stops changing. Imagine floating high above the Earth. From space, the world appears serene. Blue oceans, white clouds, dark continents, a thin atmosphere glowing softly beneath the stars. It is difficult to imagine that beneath those peaceful clouds, life is preparing one of the greatest explosions of diversity the universe has ever witnessed. Scientists call it the Cambrian explosion. Although the name suggests a sudden event, it unfolded across tens of millions of years. Compared with the billions of years that came before, it was remarkably rapid, yet it was built upon everything we have already witnessed together. Every quiet chapter, every patient innovation, every invisible microbe. Without those ancient pioneers, there could never have been swimming animals, towering trees, flying insects, or wandering human beings. Imagine constructing a magnificent cathedral. Visitors admire the soaring towers, the beautiful windows, the graceful arches. Yet almost no one sees the deep foundations hidden beneath the ground. Those foundations quietly support everything above. The first 3 billion years of life were Earth's foundation, invisible to most eyes, yet absolutely essential. Sometimes, the most important part of any story is the chapter few people notice, the quiet beginning. As evening slowly returns, the ocean glows beneath a golden sunset. Soft waves whisper against ancient rocks. Tiny algae sway with the gentle currents. Simple animals, still soft and delicate, drift peacefully through the water. The stage is finally complete. Everything that follows, dinosaurs, forests, birds, whales, flowers, human beings gazing at the stars, will rise upon the patient work of these early oceans. For nearly 4 billion years, life never hurried. It simply continued. One generation, then another. One sunrise, then another. One tiny improvement, followed by another, until an empty planet became a living world. And now, as our journey through Earth's earliest ages begins drawing gently toward its close, there is just one final reflection waiting for us. A quiet reminder that every living thing, including you, still carries the oldest story on Earth. A story that began with one tiny cell, floating peacefully beneath an unfamiliar sky. Take one final slow breath. Allow your body to grow heavy, your thoughts to become quiet, and your imagination to drift peacefully through the immense history we have shared together. The oceans are calm once again. The stars shine softly above the ancient Earth. Gentle waves whisper against silent shores. It is difficult to believe how empty this world once seemed. When our journey began, there were only oceans, volcanoes, storm clouds, and endless possibilities. No forests, no birds, no flowers, no whales singing beneath the waves, no human footsteps crossing the land. Only a quiet planet, patiently waiting. Then, almost invisibly, everything changed, not through a single miracle, not through one dramatic moment, but through countless tiny steps. Simple molecules meeting by chance, tiny membranes forming in warm water, the first fragile cells learning to survive, the first quiet divisions, the first whispers of evolution, the first breath of oxygen. Every great chapter of Earth's history began with something wonderfully small. Imagine once more that first living cell, floating peacefully beneath an unfamiliar sky. It had no idea what the future would hold. It could not imagine coral reefs glowing beneath tropical seas. It could not dream of giant dinosaurs wandering ancient forests. It knew nothing of birds soaring through blue skies, or mammals raising their young, or people gathering beneath the stars to wonder where life began. It simply lived, one quiet moment at a time, one gentle generation after another, and somehow, across nearly 4 billion years, its descendants never stopped. The chain was never broken, not once. Imagine holding a single thread in your hand. It stretches backward through time, past your parents, past your grandparents, past every human civilization, beyond the first farmers, beyond the Ice Age, beyond the dinosaurs, beyond the first fish, beyond the earliest animals, beyond the great oxygenation of Earth, beyond the first complex cells, until at last, It reaches a tiny microorganism drifting through Earth's ancient sea. That thread is real. Every living thing shares it. Every tree standing quietly in a forest. Every butterfly resting upon a flower. Every whale crossing the deepest ocean. Every eagle riding warm currents through the sky. Every tiny blade of grass moving gently in the breeze. All belong to one enormous family. A family that has been growing patiently since life first appeared upon this remarkable planet. Now, think about your own body. Your heart quietly beating, your lungs gently rising and falling, the oxygen filling every breath, the energy flowing through every cell. Deep inside each of those trillions of cells, tiny mitochondria continue producing energy, just as their ancient bacterial ancestors once did nearly 2 billion years ago. Inside every green leaf outside your window, chloroplasts continue harvesting sunlight, just as ancient cyanobacteria once did beneath prehistoric seas. The oldest stories on Earth are still being told, quietly, inside every living cell. Perhaps that is one of the most comforting thoughts science has ever offered. You are not separate from nature. You are one small part of a story that has been unfolding since the oceans were young. The iron in your blood was forged inside an ancient star long before our sun existed. The oxygen you breathe was first released by humble microbes that never knew your name. The atoms in your hands have traveled through mountains, rivers, clouds, leaves, animals, and oceans before becoming part of you. Nothing is truly isolated. Everything belongs. Everything connects. Imagine floating high above the earth one last time. The planet turns slowly beneath you. Blue oceans shimmer in the sunlight. White clouds drift across continents filled with forests, mountains, rivers, and cities glowing softly beneath the evening sky. From this great distance, there are no borders, no noise, only one beautiful living world, quietly circling an ordinary star. Among hundreds of billions of stars in our galaxy, one small blue home, where chemistry became biology, where tiny cells slowly learned to become forests, whales, birds, flowers, and people capable of wondering how it all began. Perhaps tonight, as you drift gently towards sleep, you can carry one peaceful thought with you. Life did not rush. The universe did not hurry. Everything beautiful took time. The mountains, the oceans, the forests, and even you are part of a journey billions of years in the making. So let your breathing become slower. Let every muscle soften, and allow the quiet rhythm of Earth's oldest story to gently carry you into restful sleep. The waves continue rolling across ancient shores. The stars continue shining above a peaceful sky. And somewhere, far beyond waking thought, the first tiny cell still whispers its timeless message. Continue, grow, rest, and begin again. Good night.